Okay. Hello, everybody. Welcome to SkyTour LiveStream. It's I, Marc Dantonio. I am so happy you could be with us tonight. We are here to have a wonderful night, and we're going to spend some time under the Arizona sky. I also want to welcome Daryl Mason. Hello, Daryl. How you doing? Daryl. Izabela is here, too.
Hello.
Yeah, Izabela's here. And Daryl was here. I don't know where he went. He must be on mute.
Sorry. Too many buttons.
All right.
Hello, everybody.
So Daryl was just trying to make Izabela, like, you know, feel very welcome by giving her the spotlight for that moment. And he gave it to her, so that was very nice. Izabela Melamed is from Sofia, Bulgaria, and she has done so much behind the scenes for us. And I've told you about her many times. You guys know her very well. For people that are new here, this is Izabela that you heard just a moment ago. And when you look at our streams and you look at the table of contents, that is her. She's generating the table of contents. So imagine going through the stream moment by moment by moment and taking notes and making sure that you capture the exact start time for, say, looking at a cluster or a nebula. Well, she captures it, and she also captures all the additional information that we talk about, and it goes into the table of contents for you to see as chapters, so you can just go to different spots. It's really wonderful, and I tell her all the time, thank you, that's a wonderful thing. And so for doing so, she has won herself a night under the stars for Izabela. So tonight, the whole first hour is dedicated to her objects, and if we go a little longer, well, that's okay, and that counts for anyone else who ends up doing a night with us. So Izabela, what do you think of the moon?
Oh, it's a new moon, right?
It's a waxing crescent.
It's a waxing crescent.
Yeah.
Okay. Yeah, it looks nice. Thank you for the introduction, Marc. It was very nice.
Of course, you know.
Thank you very much. I feel very welcome here.
You are.
And hello everyone in the chat. I'm used to be in the chat usually, and but I'm here now, ambassador of the lower decks. So yeah, let's go break the telescope. Right?
No, we're not going to break anything. No, actually, I'm just very happy that you could be here with us tonight and do this with us. You've earned it. I'm very happy that you could do this, and I will, of course, make sure that you have a good night. So, that said, why don't you tell us what you'd like to see tonight, and we'll see if we can deliver that for you.
Tonight I have 3 objects. 2 of them are very important to me, and I have one that I've never seen before, I believe so. And the first one, I don't know how will be the order, because maybe Daryl can help me a little bit with the charts, so which objects first and which after that. So the first that I want to see is M33 Triangulum Galaxy. Sorry, okay. English is not my language. Deal with it.
That's fine.
So,
okay.
Triangulum is probably a good first choice.
It is, because look where it is.
Farthest west, I think.
Yeah.
Yeah. So I really love this galaxy. For me, this is the most beautiful galaxy in the entire universe. Not that I know the entire universe, but what I can see. So it's incredibly rich and with very complicated. It has even nebulas like the Orion and all these nebulas. So I really love it. It's beautiful, and I love to process it because it's very rich also in color. I don't know. I think everybody in the chat knows that I tinker a little bit with processing.
You do more than tinker. You're actually quite accomplished, and you're an artist in and of yourself in your own right. So feel free in the chat to add your link to your art site as well, so people know where they can find you there too.
Yeah, later I'll do it for sure. But I have a very good mentor in processing. And
yeah, I mean, he's just a crazy person. You've done all right on your own.
Yeah.
Made great strides.
She has.
Yeah.
She's done some great jobs. I want to say hello to Vera Lucia Campos, Sam S. Vera, you were the first. Good to see you. Sam S. is with us. Anahata 77. That's Bonnie. Michael Hedrick is with us. Cyclone is with us. Daisy and Zoe Amethyst are here. And we also have, let's see, I saw another name I want to say hello to here as well. Donald Kunzer is with us. Hey, Donald. Nice to see you. And we're just getting going here, so it's going to definitely be, we're going to get going. Let me just put it that way. And Levitus1, how are you? Good to see you. I think I've seen you before. PG is with us. Hello, Petita. That's Petita. And who's Izabela? I have no idea who that is.
Izabela,
it's you. Yeah. That's great. So anyway, guys, thank you for coming out. And you're the starting up crowd, and it's going to get only more crowded from here. It's going to be great. So,
You say Vera was here?
Vera Lucia Campos was the very first one.
I don't see her.
She was the very first comment at the top.
I saw her.
I can't scroll all the way to the very top.
Okay. Hello,
Oh,
Chad
well.
Hunter. Oh, it's Shad Hunter. Okay, are you a fisherman? You say Shad Hunter. I was actually I worked at a science center some years ago, and we went to a fishway that actually helps shad to spawn. It was pretty cool. So nice to see you. And Shad, if you haven't been here before, Shad Hunter, very good. I'm glad you're good. I'm glad you're a fisherman. Shad's a great fish. There's a lot of them here in Connecticut, in the Connecticut waters, in the rivers here, and people are always talking about them and catching them. So we actually right now we actually have the moon in the view right now. It's a young, early waxing crescent moon, and we're going to hop off of this and head up to and we're going to head back up to the Triangulum Galaxy known as Measure 33. And Poison Arrow Frog is here. Hey guys, how you doing, man? If you recall, he had us look at the monkey head last time, Daryl.
Uh-huh.
That's right.
Yeah.
We
were about to leave, and
yeah.
he suggested it, and I said, Mark, why don't we go there? I didn't he gave it by NGC number, I think, and
2174, right?
lo and behold, it was the monkey head.
Yeah,
It made
yeah.
a great exit to the evening.
That's right. That's right. Okay, Levi, I got you. No worries on the shout out. We shout out to everybody if we can. Hello, Tim F. What's going on, brother? All right, let's go and head up to our next target here, the Izabela's target number 1. If you could, Izabela, remind people how long you would like this to go. What's your parameters?
My parameters are exposure 45 seconds,
Okay.
gain 300,
Okay.
and stack 15 frames.
Okay. There goes the
So this is
telescope.
my suggestion, but please
That's
tell
okay.
me.
Now, for all those that might want to join us for this, keep in mind that there's no reason for you to know any of this stuff. Okay, Izabela's just a seasoned veteran, right? So if you wanna talk to us and get yourself, say I just want a picture of a cool galaxy. What galaxies can we look at? That's just as good as saying I want the Triangulum Galaxy, which is right here, by the way, and we're actually zoomed in a little. So you're not expected to know anything when you come on with us, by the way, okay? We'll guide you if you don't have any idea where you want to go, all right? Not a problem. Okay, let's see here. So I have a gain of 250. You suggested 300?
Yes.
Okay,
Yes.
all right. And so what we're going to do is we're going to move this into the view. I'm going to frame it up nicely. Let's do that with our nice reticles. Bring it in. As you can see, we zoomed across the sky and we're almost right on top of it, even magnified. So telescope is nicely aligned.
Do you have temperature compensation on? Okay, it's supposed to get cold out there tonight, so
Yeah,
you may need that.
I know. I did not turn it on yet. I'm going to turn it on here in just a second. But what I'm going to do first is do a focus run, which I have not done yet.
Very good.
So I'm going to do it right here and then we're going to make our way. Let me frame this a little better. Okay, we'll do the circle. There we go. All right. And now center it up. There you go. All right. So we are in place. So now we can get rid of this. And all right. All good. So what we'll do is, there goes our Starlink. It was Starlink. Okay. All right. So I think what I want to do now is to take our focus out and then do the scan inward. This is what I always do in order to focus. It gives us a very, it'll go down and back, you know. But if I do it like this, if I pull it out, obviously out of focus, out, as we say out, see the word out right there, then when I use the focusing setup and the focusing assistant and I do a full width half maximum process, you see it finds this many stars. Then I can just scan in, and that's going to automatically find the parabola that we want to see. And that parabola is the parabola that that gives us, you know, our focus. And it'll be like right down here. You'll see a parabola form down here. All right. So, and it'll probably center up right around there somewhere after it finds it. So, I feel like Madden, you know, that was it John Madden?
Oh, the NFL coach?
Yeah, was that who it was?
Commentator?
Yeah. It was John Madden, right?
Yes.
Yeah, I feel like him when I do this, because I have the ability to throw this in and say, you know, hey, over here we have this guy, and this guy's going to run downfield. You know, he's going to go this way. All right. You know, all that stuff. But I do that because it helps clarify things. Now, while we're waiting for the focus, which it just found, I'll just show you, for those that haven't seen this before, this is our camera control, the telescope control system here. This is the telescope computer. This is, of course, the telescope out in the building here. Okay, this right here is some guy who just was always on camera. This is our live stacking and focusing. All of our technical stuff gets done here, and the camera control is right here. The main view is right there in the middle. Okay, so now we found our focus, so we're going to go to best focus. All right. Let me just get rid of that. All right, now we'll go to best focus. All right. So it slides across, then it comes back in and racks it into perfect focus. So now we have perfect focus here. I know it looks bright, but that's only because it's an illusion, right? Because we're using a very, very, very high sensitivity camera, and the moonlight is more than enough to give us that extra stuff there. Mm-hmm. That's right, Levi. Levi mentioned something about John Madden.
Oh, yeah. I hated the Oakland Raiders back in the day. I was a Kansas City Chiefs fan, then I was a Broncos fan when I came to Colorado.
Okay.
Everybody hated the Raiders, but both the Chiefs and the Chiefs and the Broncos had a special thing for the Oakland Raiders.
Oh, okay.
They're the Las Vegas Raiders now.
They are?
Oh, yeah, they moved to Vegas. And,
wow.
Al Davis was the owner of the team. Everybody hated him, too. He's gone, everybody's gone, and they're in Vegas now.
Wow. Well, it's windy in Vegas. Very windy. Hey, Bullwinkle. Cindy Murphy. Okay. Here we are. Okay, so we are going to do a 45-second shot. Our gain is going to be 300, and we're going to do 15 stack, right?
Right.
Okay, so
Thank you.
15 seconds. Okay, this is our guider. We're actually guiding stably right now, so I'm going to go right ahead, take us out of what I call night vision mode, All right, and the screen's going to look like it's going black. Okay, but it's really not. It's acquiring data, and I'm going to go into the live stack. This is our region for technical processes here, and this will be populated by the data curve. So you'll see where the data is. And there it is, right there. And we're going to let it tell us where the data is. Hey, look at that.
Here.
Right there. Look at that.
Isn't it gorgeous?
You want a 45-second exposure?
Oh, did I do 14? I did. Sorry, Izabela. I screwed that up. My mistake. But hey, if you think about it, a 14-second exposure doesn't look bad. Let me do 45, though. I thought I said 45. Yeah. I must have mistyped. My mistake.
I heard 45.
Yeah. Okay, so...
It's good that Daryl watches it.
Oh, look at that. It's doing a new one right now, but check this out.
Okay.
Wow, look at that. You can really see the H2 regions. These are hydrogen regions in here. Really nice. So I'm going to clear this because we're going to bring it in again. Okay. Oh, man, I didn't know that. Okay, so let's pull out a little bit here. And all right, so we have 10 seconds left on this exposure. And we'll see what we get. Here we are, and we're gonna move the curves to get it better. Here we are, and we're gonna color correct this. Okay, there it is, and we'll zoom back out here a little bit. That looks like the guiding is good, Izabela, so this should be a good little exposure.
Very nice.
And we're gonna say up here, right up here, we're gonna put the data for what this is. This is M33, Measure 33, Triangulum, not Yatsmo, what the hell's that? Oh, my hands are in the wrong keys altogether. Sorry about that. M33, Triangulum Galaxy. There we go. All right. Oh, yeah. The Triangulum Galaxy is like 2.7 million light years away, at least. It's thereabouts. And it's in physical proximity to the Andromeda Galaxy, which is just there, farther out that way, about there. And it's actually probably had some type of interaction with the Andromeda Galaxy in the past. But if we look at it closely, you can see that its spiral arms are kind of loose. They're not tightly wound. So it's classified as what we call an SC galaxy. And that's S, and probably the proper statement, a proper characterization is this one here. Okay, M33 and SAC. All right, so it's a spiral, and it's a C type where the arms are not very tight. If it was very tight, it'd be like a SAB. This is a new mechanism for nomenclature for galaxies. They used to be SC, SA, SB, but now they've changed it a little. Andromeda is like an SAB, where it has slightly tighter arms. As you can see, we have stacked 4 already, so we're cranking along. And as you can also see, there's an awful lot of our frame left here.
Marc, I have a question about this
Sure.
galaxy.
Yeah.
Actually, this is one of the main reasons that I chose it.
Okay.
Recently, I read a very interesting article about a team of scientists, of astronomers and computer scientists, which produced a very, very detailed image of the Triangulum Galaxy, and they managed also to separate the stars by the age. And they produced a picture only of the very young stars, which are younger than I don't know how many million years, but they're young, and big stars, the giant stars, and
Okay.
a separate image only of the small stars, the M stars.
Okay.
And they found out something very interesting, that this image of which we are looking at, of the Triangulum Galaxy, it actually looks like superimposed images of two different galaxies. The one that is made of the young stars,
Like here.
which has this flocculent, how you call it, knotty view, and very rich view, and with a lot of sparrow arms.
Mm-hmm.
And the other one, which is of the older stars, which has completely different structure, with a distinguished bar in the middle and only two arms, sparrow arms. So it was very interesting, because I just couldn't. My first thought was that how was this completely two different galaxies, like in one single galaxy, how they got together. My first thought was that it was like maybe M33 was created by a collision between two different galaxies, one older and one younger. But the match is so precise that I don't think it's possible. It's perfect match. My other thought was, I was thinking about this the traffic jam theory, the density wave theory.
We've talked
Also
about
doesn't
it, yeah.
work, because it will be the same for every galaxy. So what is your idea about this? Why these two different galaxies in one?
Well, okay. Let's address the first thing first about the density wave theory. Density wave theory works for some galaxies, but not for others. Okay. For instance, there's two mechanisms that we think might be responsible for creating spiral arms in a galaxy. One of them is the density wave theory, which is the traffic jam hypothesis that we've talked about before. In that one, stars are born in a thick congestion in the spiral arm, and then they end up moving out, and other stars orbit through, but they're also kicked around a little bit by the gravitational forces in that area, but they keep going. So it's like a car, a red car getting through the traffic jam over time, but the traffic jam is still moving along slowly, right? But the red car can go through it over time, and the blue car and the black car over time. So it's not the same stars in the spiral arms all the time. Okay, that's the density wave approach. The other approach to making spiral arms is collisional disturbance. So in the case of the Whirlpool galaxy's spiral arms are thought to have been generated by the collision with that satellite galaxy that you see at the end of the tail of the Whirlpool. So there's two ways. So in this one, with two different sets of spiral arms, it might be that there's two mechanisms in play that we actually don't understand yet. One is certainly going to be the density wave hypothesis, possibly working to create spiral arms. And the other one might be something completely different. Maybe that resulted from a near miss with Andromeda, and maybe that set of spiral arms was generated by a near miss, and the arms we see visually here are created by density wave, or vice versa. It could be the other way around too. So it'll be interesting to see whether this galaxy's primary spiral structure that we see visually, like this, okay, was created either by density waves or by near misses or a close orbit to Andromeda, because we're only seeing a snapshot in time.
I saw those images you're talking about, the article. The difference was very striking. As you say, the one image, you called it flocculent. It was just a big, kind of very loosely wound galaxy, not very clearly defined spiral arms. And then the other one showed very distinctly two spiral arms and a bar in the middle connecting them. It was very fascinating images.
Now, just curious, Daryl, do you remember the image in your head? Was the bar right here, going this way, by chance?
I think you can faintly see the bar there. From about 9 o'clock to 3 o'clock or so.
Yeah, that's what I mean, it's funny, because I've always thought that this galaxy had characteristics of a bar, through the middle. And apparently, the discovery is borne out by that research. I think that's pretty cool.
It really did look like two different galaxies almost. You know, the two arms are much more sharply defined in the one image than in the other.
Mm-hmm. I'm guessing one is like this and the other one is like that. Right? Am I right? It's this one and this one?
I would have to go find the article again.
Okay, no worries. Well, Izabela, we're at 12 exposures at 300 now and 45 seconds. So, what do you think?
Time flies. This is what I think.
Run.
I think that I will be processing this tomorrow. And,
well, you know what? Out of deference to you and the fact that this was your night, I will let you do it first.
Yes,
I won't touch it.
Thank you.
And then next stream we'll let you preview it for everybody so they can. Oh, I know who that was.
Uh-oh. I know who that was.
I'm
that was
sorry.
Somebody's puppy. Oh, stop.
I'm sorry.
We love puppies. My dog is around here somewhere.
Yeah, but your dog is probably not hanging from your hand right now. Okay, I'll go a little bit offline, so.
Not a problem. And it's not a disturbance.
Okay.
We love dogs.
That's funny.
She's gorgeous. Gorgeous little puppy.
Pull this
Little
out of
shark.
there. Yeah, she bites you.
A lot of exercise and wear her out so she'll sleep.
Daryl was going to say, shut up.
I wasn't.
I thought you were. You said, sleep.
Shut up, baby.
She's cute.
Shut up, puppy.
Okay, we're going to close in on 15, and we'll let it go a couple more. Because you want Hind's Variable Nebula as well. And let's go find out where Hind's Variable Nebula is comparatively. We have the Poor Man's Double Cluster, though, right nearby, if I recall. It's up here. Right there. Or is that the regular double cluster? Ooh. Yeah, that's a regular double cluster. Okay, the Poor Man's Double Cluster is somewhere else. I gotta remember where that was. We'll find it. But whatever is closest, whatever's westmost, we want to go to. And so far we did Triangulum. I know that nobody in the chat has got any problems with her doing that. I think that's hilarious. Okay, that's still east. So what we'll do is we will go to Hind's Variable Nebula, but that's down here, I think. We might have to wait for that, so we may have to do this one first. I think Hind's is... okay. Yeah, we can see it. We can see Hind's. We'll do Hind's.
Do you want to introduce it? Because I wrote something very long that there is no way that I can reproduce it.
That's fine. He wrote it in the Skype. I saw it. Look at this.
Yeah.
Isn't this beautiful?
It is gorgeous. I'm going to hang it on the wall.
Oh, yeah. I'm going to hit it. I'm going to put an unsharp mask on it. Let's see how that makes it look. Look at that. All that detail just got really sharp. See that?
Can I move back out just a little bit?
Yeah, why not? I got to see the whole galaxy. There we go.
See lots of paint stuff going on there.
I do. I want to color correct too. There we go. Look at this halo around it. This is a real thing. This isn't us causing this. I'm not causing this. This is a halo. It's really there.
Got one of those supernova remnants way down at 5:30.
Right there.
Yep.
Yeah. In fact, that's a good thing to point out. This galaxy has a lot of these green remnants, right? We have one right here. Okay. There's a tiny one right here. There's another one right here. Okay. And look at, there's another one down here. There's one, where's the other one up here? Right
one
there.
Right at 3 o'clock, yeah.
Right there. And there's another one down here somewhere. Well, anyway, these are what I suspect are supernova remnants. This is what, for instance, the veil would look like this sort of from here. From there, you would see it kind of like this greenish O3 oxygen with 3 Roman numerals is the O3. That stuff is the ionized oxygen, doubly ionized oxygen, and we definitely see that. I think that actually it was up here. I think I did.
That H2 area there.
Oh, this
about
guy.
10 o'clock, yeah.
Is that 604?
NGC 604, yes.
Let's zoom in on that. And we're still stacking.
nursery.
We're still stacking for you, Izabela, just so you know.
Where you can see how many are stacked?
Right here. And down here.
Uh-huh.
Can you read that?
Yes, yes. I see.
Okay. If you guys can't read that, make sure you're in 1080, 1080p on your stream. Okay. This is really pretty. All right, so we're gonna just drag this. I'm gonna actually try something else. I'm gonna cut off the unsharp mask for a moment, and okay, there's another one right there. Look at the detail. Look at the detail in this supernova remnant up here. You can actually see detail that's really cool, and if I hit the unsharp mask on it, you can see almost the shape. It almost looks like a Thor's helmet, which is not a supernova remnant, but it has an interesting lobed shape, which is really interesting to me. And then we have all these H2 regions, all these stellar nurseries like the Orion Nebula. Okay, we've got one here, the big one, NGC 604, as Daryl mentioned. We have this one up here. It also has a name. And then we have the other one down here. This one's rather extensive. It kind of looks like what would be the Eta Carina Nebula in our galaxy. But there's a lot of really interesting stuff going on in this galaxy. But at 2.7 million light years or so, it's still got some pretty cool detail for us to see, even at that distance. It just means those features are very, very large. Okay, all right, we're at 22, Izabela. We're gonna stop it here. And
Would you like to see the images that Izabela was talking about?
Yeah, drop them in the chat.
I will.
Okay, so Izabela, we're gonna save it here. I paused it. All right, it's labeled, and we're gonna save the astronomical fits format, which you're gonna work with, and then the save exactly as seen, so people get it just like this.
There it is in your chat.
Yeah, I see it. All right. So while we're waiting, let's show people. Okay, what we were talking about was this right here. Okay, this is the same thing, but just seen from a different orientation. This looks like NGC 6. Oh, I'm in the way. I'm in the way of the broadcast. Let me come over here. This looks like 604, isn't it? Right there.
Kind of looks like, yeah.
And this is that other one. It's a segment, right? And you can see these spiral arms. It looks very different. You see, there's the bar, and then it goes like this: one spiral arm, one. And these red stars, these many dots. These are probably those older M stars. And these stars here that have blue in them, the blue spiral arms, these are the young hot stars that are formed in those spiral arms. Very cool. Very neat.
The article, I'll post a link in the
All right.
chat.
Fair enough.
Thank you very much, Daryl.
Sure.
And Marc.
Of course. All right. So we've saved this now. So say goodnight to it, Izabela, because we're going to go now to your next object. And we're gonna pull out of the
were
galaxy.
the right pictures, weren't they, Izabela?
Sorry?
It did not look like M33 to me. M33 is more skinny. Wasn't sure if that was the right galaxy or not, but I was speaking to the fact that they do show two separate things.
The pictures I passed on that Marc just posted, were those the ones you were talking about?
No, I don't think that was the picture. It's in it's in the chat room.
I do remember that picture though. Not sure. I mean, that looks like this galaxy on the right is not Messier 33, by the way.
No, it is not.
The one on the left is. Doesn't look it.
Figure 1, figure 2, you can clearly see the split between these two stellar populations.
Yeah, but
no, I take that back. Okay.
Yeah.
Let me post the link.
I think they're showing the difference in the stellar populations, but they're not Messier 33.
My mistake. The one on the right is M101.
Right, that's right, the pinwheel.
Okay, but the article is talking about that.
Okay, very cool.
My bad, I apologize.
No worry, you're not a bad astronomer. Don't beat yourself up for it. We all make those mistakes.
Bad astronomer.
Bad astronomer, go lay down.
There it is. Izabela had it up.
I don't see it in our chat.
She just posted it in the group chat.
She did?
Yeah.
Okay.
Yeah, it's from physics.org.
All right. Well,
Yeah. My bad.
I don't see it. All right. I don't see it in our group chat here. Anyway, it doesn't matter. We'll get it another point. Oh wait, there it is. All right, it just came in. Okay. Yeah. Okay, the image that she's showing, let's just go in there for a minute. We have the Triangulum Galaxy 1, 2, and 3 in different filters, different lights. Okay. And I think that's it. And then here is the Triangulum Galaxy overlaid, so you can actually see it all together. Pretty neat. All right.
Yeah, that's it.
All right, cool. Well, thank you guys for hanging in, all of you out there. At this point, all I can say is I kind of like this one.
I love it.
It is beautiful. All right, here's what we're going to do.
Very beautiful.
We're going to clear it next time around. And we're going to go back to our 1 second night vision mode that we talk about all the time.
I like that big, like an OB association down there at 6 o'clock.
Oh, yeah. Yeah. All right.
Below the main body.
Mm-hmm. Okay, so next we're going to do Hind's Variable Nebula, which is right here. We're in this now. We're going to tell us to go there now, because Izabela is telling us what to do tonight.
Please do exposure 90 seconds, but you're not there yet. Yeah?
Don't worry, I will, yeah.
Exposure 90 seconds, gain 300, and stack 15 frames.
Alrighty.
It's a challenging one.
The Solarian view reminds me when we saw Mars there,
Mm-hmm.
that Mars has resumed direct motion. You're going to see it move east and leave the head of Taurus and go into Gemini, and it's going to keep moving for months and months to come across the zodiac before it disappears into the sunset.
Okay, we're going to do a 35-second exposure to begin with, just to check position. I think the nebula in it is right here, but we're going to see in a moment. I'm going to put my cursor where I think it is. It should be there. This is just to catch the location. Actually, it might be here. Well, depending where it is, I'll center us up. Or it might be there. Okay, we'll find out. It's very high in the sky. As you can see, the telescope's looking almost straight up, so we're good. All right.
You guys see why they call it the poor man's double cluster.
Okay, let's go see here now.
Let's go see.
Yeah, I missed. I think that's it. Yeah, that's it. Okay. So we're close. So what I'm going to do is I'm going to bring us back to the 1 second and move that guy up to here. That guy. Because that's where we're going. Now we're going to go here. And that's enough because we got detail to the left that we want to see in this one. All right. So now we're going to go searching for our guide star. You'll see right there. And then we will start our 90 seconds after we stabilize. 90 seconds is a minute and a half. And 90 seconds is it. It's set. We are stable. And there we go. Off we go. Now we'll go into our stack and you'll see the Measure 33 in the buffer from the last shot. And we can still move it around and check it out and stuff. We have 90 seconds, so let's go check out what Darryl was talking about. He says he likes this very bright OB association. Talking about this one here?
Yes.
Okay.
There's a bunch of them going on there.
Oh yeah, there are.
That one in particular.
Yeah, we've got these hot blue star regions right here. We've got them here. We got a group right here, another group here, another group here. It just goes on, and we have an extended group here as well. Okay, so that's pretty cool. They're all part of this galaxy, and these are all. Of course, I missed one right there. So these are really interesting. They're hot young stellar formations, O and B stars. They're only going to live a few tens of millions of years, and then they're going to go supernova and litter the interstellar medium with more of this dark material that you see, throughout here. This, like in the center around the spiral arms there, you see it. So we got a lot.
Curly Q shape when they're to the left was the big one too.
That's true. That's true. Okay, well, time to clear it because we have another exposure coming in of Hind's Variable Nebula. The first one is going to be noisy, and then after that, we should be good. Here we go. Let me get us out to... where is it? I don't see it. How come I don't see it? Maybe because I gotta...
I think it's there. It's
oh, it's right there.
Center
there it is.
upper. Yeah.
Good. It was where I thought. I was just like, huh? Where'd it go? I was flash blinded by how bright it was. This is an example of an interstellar dust cloud where a star formed in it, and the star is actually ionizing the hydrogen gas, which is also mixed in with this dust cloud. Hydrogen's the highest. Let's talk about abundance. The highest abundance of hydrogen in the universe. I'm sorry, the highest abundance is hydrogen in the universe, second only to helium. And then what's next is actually interesting. We have hydrogen, helium, and then we have oxygen being very abundant, followed by carbon, which is the fourth most abundant in the universe. Isn't that crazy? So,
Hind Nebula?
This is Hind Nebula. See it?
My bad. I thought we were going to the 4 minutes double cluster.
Oh, yeah. Sorry. No, it's okay. We did talk about that, but it's actually still... it's more to the east, so this one is a good target to do first, then we'll go to the 4 minutes.
Okay, I recognize it now, yeah. My bad.
No problem. You're all right, man.
I'm a bad astronomer.
Well, if you keep saying that, people will start believing it.
Yeah.
Nonsense. Okay, so let's do this. Let's give our horizontal axis something to play with here. All right. Oh, hey, Ray, thank you for putting that up, but NGC 1555, not there yet. Hey there, M. Turner. We will be looking at the comet as soon as it rises up high enough to be a really cool view, a view that is not to be missed. Jeremy Blaine, welcome. How you doing? Water is a molecule, Jeremy, so it is abundant, but what is water? It's hydrogen and it's oxygen, isn't it? Hydrogen's the most abundant, oxygen is the third most abundant. So, in a sense, you're kind of on the right track, right? So, a water molecule, there's a lot of water in the universe. You know what? And that's something that's really changed over time. We started to realize, you know, as science folks, that the abundances in the universe are way different than we initially thought they were. In the 60s, no one thought that, you know, they'd find water out there in such abundance. And in fact, no one ever thought we'd find water on the moon. But water isn't on the moon like it is on Earth. It requires pressure to actually be a liquid on Earth, and if the pressure gets lower, then water will evaporate and just disappear and become water vapor and not condense and become clouds that would then rain once they get laden with water molecules. But on the moon, we would need high pressure to form any kind of standing water, and we don't have that. And because the moon is somewhat porous, it can't exist under the moon either, like on Mars. At the South Pole, underneath the Martian South Pole, is this kilometers-long area that's actually an underwater reservoir, like an aquifer. You know, it's really cool.
Did you see? There's a article I just saw yesterday. They think they found a huge reservoir of water on Mars. It's found with radar by estimates that's operated jointly by the Russians and the European Space Agency.
Yeah.
It's in Valles Marineris, and it's like 3 feet below the ground.
Yeah, that's not the one that I was talking about. The one I was talking about was found by radar as well. So that find is on the heels of the find 2 years ago of the South Polar Subterranean Reservoir. It's over a kilometer down. So there is the Valles Marineris Reservoir now, and now we have the South Pole Reservoir from before. So as you said earlier, M. Turner, not M. Turner. Who said that about the water? Was that Turner?
Jeremy
Blaine. Okay, thanks, Jeremy. Sorry, Jeremy. Yeah. So from what Jeremy said, water is very plentiful, and we find it everywhere. It's on comets. It's on asteroids. Not all asteroids. Okay, Vesta is actually quite dry. Ceres, on the other hand, is quite wet, and that's why the Dawn spacecraft went to Vesta first. All right, and then went to Ceres next. And Vesta is again a very interesting asteroid. It's got a weird, it's sort of oblong shape. Actually, I'm looking for something right now that I want to show you. So, where is it? Sorry about this. I must have moved. I had Vesta here. I was going to show you. Oh well. I had 3D printed a model of Vesta for you guys, and I can't find it now. Okay. So yeah, so water is very plentiful. Ices of various kinds are also very plentiful. Keep in mind that when you look at the interstellar medium, there's an awful lot of ices that are found out there. There's methanol, formaldehyde, water ice, carbon dioxide ice, ammonia ices, okay, and more. In fact, the James Webb just did a study that showed a tremendous amount of ices that were present in a variety of forms around the universe. And I think that's kind of interesting that we found those, especially with the James Webb Space Telescope. It's really worth its weight in gold. All right, I'll give you an example because. Okay, here is an example. This is the near infrared cam. Carbon monoxide, methane, all right, CO2, ammonia, all right, and so forth, and peroxides as well as other materials. And it's found so many different materials out there already. And this it's finding by looking in planetary atmospheres. It can see the planetary, in other words, exoplanet atmospheres. Very nice. Very nice. It was definitely worth its weight in gold.
I mentioned in chat, they were asking about comets. There are actually 3 comets up right now.
Yeah, I was going to say to you that I saw that Mike asked that question. Is there any comets we can see right now?
Well, ZTF is the big one.
Yeah, that's.
There's Comet Machholz, but that's down south in Microscopium. I don't know if we could see that or not. And there's also C2022A2 Pan Stars is also in Draco. So A2 and E3 are both in Draco right now.
Okay. All right. Well, we'll look when and if we can. Guiding is good. There's that interesting. That star is ionizing the hydrogen that's in here, as I said, and that's why you got this thing. One thing to notice too is the star apparently has started to form a cavity around itself, and this micron-sized dust is being pushed away over time, and that's my guess anyway. And this hydrogen might be further away into the page, and so it might show up as ionized, but we don't know the distance. It's certainly not right next to the star, right next to the star. That doesn't have to be. And there might be more ionized hydrogen behind this dust cloud that we can't see. Interesting stuff.
Comet 2022 A2 Pan Stars, 10 degrees up in the northwest right now. That's from Colorado.
Okay.
So you probably wouldn't be able to see it.
No.
It's over to the left of ZTF, Comet ZTF.
Okay. Well, ZTF is what we're waiting for anyway, so we'll see ZTF.
Yeah. I think ZTF is brighter of the two.
Michael, I put T-Comp on just now. The drift hasn't been a lot out there right now, and when it changes by more than a half degree overall, then the T-Comp comes into effect. So I put it on because we dropped now to 6.9 from 7.3 or whatever we were. So that's just to keep our focus sharp. Hi, Alice. Alice has joined us.
And Comet Machholz is basically it's lost in sunlight right now.
Yeah. Jeremy asked a question, which comet has the best chance to become naked eye visibility? That would be 2022 ZTF, basically. Yeah. Found by the Zwicky Transient Facility. and that's the comet that would stand the best chance of being seen. And you can see it probably in binoculars once it's above Polaris. I would think you might see it. It's gonna be a little tiny patch.
Yeah, and it may be visible naked eye, but you'd have to get out in the dark country skies probably to see it naked eye.
Or here. Hey, go here. See here. This is.
There.
It's very dark here. Yeah. Now, while we're waiting, I did want to bring up one other thing here, just to show you.
Right.
What's that?
Let me go back and find it.
All right, I'm gonna go in here. Just a minute. All right, we're gonna do a 15,000 millisecond. Okay, 25. No, 15.
ZTF is above the horizon, both for myself and Marc right now. But let's see, what did we say the other night? You're 6 degrees farther south than me at about 33.
We're at 33.
Yeah, so it's about 7 degrees above the north-northeast horizon for you right now. And how high did we figure you'd have to be to see over the wall of the observatory?
Well, that rear wall is toward the north that you guys see there. Looking at this rear wall, okay, over the top of the observatory there, that would take the telescope to be just about 30 degrees, maybe 29. Yeah, so it wouldn't be visible. Okay. Not until it's basically it has to be level with Polaris. Alright, so here is the AllSky camera out here right now. Let's show you that.
You could wait till about 3:30 in the morning, it'd be high enough to see.
Oh, I'm sure it will. You gonna be awake?
Not me.
Yeah, exactly.
Well, actually 2:30 in the morning.
Alright, so here, this right here is Orion. You can see it here in our AllSky. This right here is Aldebaran and the Hyades. That's Mars right there. There's the Pleiades right there. This is right here. That guy is the Auriga's here. This is Capella. And that's Auriga there. I don't know what that was. That's not Gemini. Gemini's up here somewhere, I thought.
Nope, that's Casper.
Oh, Casper, duh, yeah, okay, because I think you can just barely see Mesha 35 down here. Yeah, okay. And then we have Sirius right here, the brightest star in the northern sky, brightest star in the sky, and then Procyon right here. So this is our winter star set right here. And as Daryl said, it makes a rough G, as you can kind of see. I didn't do all of them, but, that's what that looks like. Nope. So there we go. And we'll leave that up a little bit later. We'll come back and refresh it. All right. So we are at 11 here, Izabela. You still with us?
I'm still here, just
How's
muted.
the dog? How's your doggy?
The dog is playing both, so I can mute here the chat, but I cannot mute the neighbors downstairs.
Uh-huh. Look at this. You can actually see now. You can see the separation between these dark clouds and the black of space behind. Let's play with this a little bit. Okay, let's see what else is there. We're gonna go here, kick that up. All right, so now you see what's actually there. This gives you a better feel for what's in this frame. See all this dust? All this dust is here. It's amazing how much is actually in space there.
That's looking good.
Yeah, and we can do a color correction, and you can see it even better. But I'm going to remove that artificial pumping up of that, and I'm going to try and do a more targeted raising of that brightness, just to give us a little better view. All right, so what do we have here? All right, so now let's bring this in just a bit. And then take this in just a bit. All right, here we go. There's a lot going on here. Let's see where it wants to go. Okay, it wants to go there. Bring this in. Oh, look at that. There's a lot happening in here. All right, darken that right up. Wow. This is neat, Izabela.
Are you still?
This is the best image of this nebula.
Yeah, and there's a lot to process too.
Yeah, and frankly, I tried 3 of this nebula, but this is the best, definitely.
Excellent. Well, it is pointing straight up, so it's going to give us the most data, and it is at only 300 gain, so it'll only be moderately noisy.
Are you still doing unsharp masking?
I am. I could shut that off, and then it'll look like this. So, I mean, we can turn it on as needed. Let's see if it did knock down a little bit, yeah. Okay, we're at 13 now, Izabela. 90 seconds though. That's pretty good. Good plan.
31.
Huh?
Yeah, that's double than I wanted. Thank you very much. That's excellent.
No, it's not double. We're at 13.
13. I hear 30.
No,
Okay.
see, it says 1, 3.
Two
That's
more.
how many are stacked. Yeah, and then 90 seconds.
Yeah. No, it's excellent.
Clouds
It's really
coming
very
out
good.
now.
What'd you say?
The cloud is really coming out now. The
I know.
darkest part.
It is.
And these 3 streams of hydrogen gas, also very clear. It's
Yeah.
distant gas, probably.
It is.
That'll make a pretty picture.
It will. And I know Izabela will pull it out, and then I'll do the same. And then Izabela will say, "Oh, I like mine better," and then she'll say,
I do this sometimes, I admit.
I think that's funny.
I have to encourage myself.
That's okay. We encourage you. Hey, Ronald is here. ERRT Radio, heard only on Mixler. That's Ronald at ERRT. Go there after the stream. Listen to what he's playing. Who knows? Ronald says you sound nice. Izabela.
Thank you, Ronald. I can't wait to hear you here. Do we have an idea, Ron?
Oh, yeah.
Yeah, he does?
I've met him in person several years in a row now at Pine Bush. He drives 22 hours from Minnesota, which is in the middle of our country, all the way to the East Coast to New York for the Pine Bush UFO conference. Pretty interesting, you know. All right. Michael Hedrick says, look how it reaches across the sky. No, you're right, Michael. Look at this. Like that. It reaches across the sky. It's also reaching up this way, by the way, and down this way, incidentally. It's like 3 strands. 1, 2, 3. And there's more out here. Let's zoom in to this just a moment and look at this internal area right here. Okay, obviously we're a little too close right now, but the guiding is still good. But here is that emission nebula that's caused by this star in here Here's the densest part of the nebula from our perspective, thinnest part, all right, and then we have strands of relatively dense material in here. And then it kind of reminds me of another one that I have as a favorite called the Iris Nebula, except it's not an emission nebula that's lighting up the iris. It's a reflection nebula. It's just blue scattered starlight from the one star that formed in the middle of this dark dust cloud out there. Again, dark dust has plenty of hydrogen in it as well.
And the star lighting up the bright part of the nebula is T Tauri.
It's a T Tauri star, right? A hot young star that are known for being rather unpredictable, and that's why it's a variable nebula, because this nebula will either brighten or dim based on the activity of this T Tauri star named, well, as is it's T Tauri itself, correct?
Yes.
Yeah.
It's the T Tauri.
Right. It's the T Tauri star, which is the namesake for all stars of its kind, which are these young stars that are extremely turbulent in their youth, and so they have flares, they have brightening and dimming as they stabilize into their final main sequence lives. Main sequence being where they fuse hydrogen into helium like our sun does. As you know, our sun is more stable than a T Tauri star. And welcome, Michael Klagas. How are you? Cosmic Ray, I don't think I said hi to you. I talked about you, but I didn't say hi to you. Hello. It's neat seeing, you know, we talk about T Tauri stars all the time. And this particular star is where it all began. When we talk about the T Tauri family of stars, this is the very star where it all began. And we can just take another peek, because we're up to 16 stacked right now. And we'll go a little more. See that? Look at that. Carved out a chamber in there.
T Tauri star is a protostar, right?
No, it's actually a star that's a full-blown star, but it's very young. Okay, we just grabbed another one. Look at that. Boy, that's pretty.
T Tauri stars, as far as I know, they have to be no more than 3 times the size of our sun. So the astronomers believe that our sun once was a T Tauri.
Don't you be barking at us. Isabel's barking orders at us. Yeah, our sun was once young and unpredictable as well. I'm going a little longer on this, Izabela, because I want to actually give you the right... Since it's a dark nebula, you go a little longer to get more of that dark data, okay?
That's going to make a nice picture.
Yeah.
You see just below T Tauri, looks like there's one sharp, skinny wisp of nebulosity.
This here?
No, over to the left.
This?
Little, directly below T Tauri.
Okay.
There's a real skinny little wisp of right below your pointer.
Oh, right there.
Yes.
Oh, yeah.
There's actually another one just to the lower left of T Tauri.
Well, let's go a little closer.
Very
then.
skinny little.
We got to be careful. We get too close, and it's really, really hot, unpredictable. It could be dangerous to our spacecraft. Yeah, I mean, we got this little guy right here. We've got this thing right here. Look at that. There's a lot going on there. That's really pure, really just in its pure form, one of the most beautiful sights in the universe. Seeing a young star. It's a toddler. know. Hello, Carbon Star.
Michael Clegas, the comet is above the horizon, but it is very low, especially to see from Arizona right now.
Yeah.
High
Michael's.
enough to see from here or from Arizona until about 2:30 in the morning.
Yeah, we got a ways to go.
It's climbing higher and higher night by night, though. Hopefully we'll be able to be in a good spot to see it in a few days.
Okay, let's pull the view in here and let's go full screen, shall we? There we go. Very nice.
And you can see that big dark curl over to the left of,
Oh, yes.
to the lower left and left of T-Tauri now, too. That's going to make a really pretty picture.
I think so. Michael Hedrick also asked a question which I'm going to address here. Let's talk about the smallest stars in the image. The smallest stars in the image might be very large stars at a great distance. We don't know. So that's the thing. The biggest stars, like this star right here, that's right here in the image, in all likelihood, it's probably a fairly moderately bright star. And that tiny little red one right there, that might be a red giant very far away. So it could be much bigger than this star, have much more luminosity, intrinsic brightness because of its radius, but it might be too far away. It might be much more far away. So we don't know, but in general, the smaller red stars that we see in any image, like let me make note of them. Okay, for instance, well, we have one right here. Okay, we have one. We have two right there. And I could go on all night, circling little red stars, okay? And these stars are all potentially M dwarfs. Type M, surface temperature about 3,000 Kelvin, not very hot. And if they have a habitable zone for planets, it's going to be really close to the star. So that planet's year might be 7 days, a week. And be in the habitable zone, okay, kind of like TRAPPIST-1. So some of these stars are going to be those small ones. Some of them will not be. Some of them will be red giant stars very far away, because we don't know if it's a small thing up close or a much larger thing far away until we actually study them and get their distances. And to get their distances, we use a tried and true set of techniques that collectively are known as the cosmological distance ladder. Everything from parallax to find the distance to nearby stars out to about 300 light years, all the way to using Cepheid variables to get the distance to galaxies, and type 1a supernova to even get distances to further galaxies. So there's some really interesting ways in which we obtain distances, but not every single star has a distance measurement given to it. Not every single one, because that's quite frankly a lot of stars. So, and Michael is trying to point something out, and I missed it. I'm sorry. He's asking if it's a binary. Okay, you'll find stars, for instance, like these two little ones right here, right? See those two little ones right there? You might say they're so close together. Are they a binary star? Maybe not. You can have this star way up here and this star, several light years behind it. Okay? So it could be line of sight, because when you have this many objects scattered randomly in the cosmos, you're going to get a lot of things that look like they're right next to each other when they may not be. Okay? When they may not be.
Ronald, you say, okay, in the dark areas of the nebula, is that star forming areas? Yes. In a word, the bright star you see lighting up the bright part of that nebula, that's T-Tauri we talked about. That's a young star, and it probably woke up inside that dark nebula.
It sure did.
It looks almost like I see a little bitty star to the lower right of T Tauri in the darkest part of the cloud. Might be a foreground object, but it might be in the cloud. There are probably other ones popping up in there too.
Yeah. That's the thing about these clouds. You're talking about this star right here?
A little bitty one to the lower left of where you are.
In here?
To
Or
the
is
lower
it that
right,
one? It's
straight
not
down
that star?
your pointer, straight down.
Oh. Okay.
Just to the left. That little bitty one right there, you're covering it.
Oh, that one right there.
Yes.
Okay. Yeah, that's the other thing too. When stars are inside these nebulae, then a lot of their blue light gets scattered away, and there may not be enough of it going on to make a bluish-looking nebula like around the Pleiades that we see. But we will see the stars that are inside a nebula will look redder, and that's interstellar reddening. And so, like, the sunset is red because more air is between us and the setting sun, and more scattering is going on by the atmospheric molecules to take the blue light and scatter it around, which is why our sky looks blue. All right, and so that leaves only the red light to reach your eye. So the sunsets always look red. You know,
You've got a very reddened star at about 11 o'clock from your pointer.
this guy. That one?
Yes.
Yeah, that one's red. Not sure if that's a foreground object in the cloud or not. But, alright. We're going to go to 24 shots. This will be the last one. And then we'll move on to her Poor Man's Double Cluster. I think this is going to look pretty.
Yes.
Let's see some processing on it.
What's the detail coming out in the cloud?
Yeah, we had to do more than 15 stack. That's what we're here for, right? Is to make sure that people know that we're going to help them get the best for their participation. All right, so let's back out of this now and see what's in here. Okay, so there we are. Now let's do this. Okay, pull it back.
Ronald, there's one counter at the bottom right. And there's another counter over on the bottom left. A little higher up.
Oh, for how many are stacked?
Yes.
Oh, Ronald, I'll show you. If you look right here, Ronald, that's the first counter. Right now it says 24. And the second counter is right here on the bottom status bar, right there. Right? So we have one here and one here. All right? Those are your counters.
Marc got a new toy.
What's that? Is it called a telestrator?
Sure, why not?
It's a telestrator, which is being able to, superimpose things on the screen.
Yeah.
I mean, it's very helpful, though. It's important to be able to show what you're looking at.
Well, that was the first time I saw those big red arrows.
Oh, you didn't see those? Oh, okay.
Not before.
All right. Yeah, I apologize. I guess I should have showed you. New toy, yeah. It's kind of. I mean, I could use them to ad nauseum, but that just gets old. All right, so let's see if we can do some.
The dark
final.
hook. It looks almost like a reversed image of whatchamacallit in Massachusetts. The bay.
What does?
The dark hook and nebulosity there.
Right here?
Yes. It's almost like a backwards whatchamacallit bay in Massachusetts.
Cape Cod?
Yes, Cape Cod.
Okay. Yeah. Very cool. I also see an interesting object right here, I think, that is worth looking at. If you check this out. See that? There's something going on in there. Not sure what. Not sure what. Okay, we're at 25, Izabela. We're gonna save this, okay? And we're gonna name this Hind's Variable Nebula.
Thank you very much, Mark.
No worries. By the way, what's your dog's name? I forgot.
Sky.
Sky?
Full name Clear Sky.
Clear Sky, okay.
Clear Sky.
Good. I love it.
When she's a good girl. When she's bad girl, she's burnt out 9.
And bites you.
Yeah. She.
Oh, good girl always bites her mommy. There you go.
Yeah.
Okay. You got it, Izabela. Done. So let's back out. That's going to be really pretty, Izabela.
I really like this.
I might process that privately and you won't know it. I won't publish it until you do.
Okay.
Green Cat has a question of you.
Okay. Oh, hi, Green Cat. How you doing? Have you tried the gradient removal and the pre-processed background removal in Sharp Gap? I haven't. I got the flat field going on, but down here, what you're talking about is one of these pre-processing systems. I could do a dark subtract, which I'm not. I'm doing an apply the flat. All right, but I'm not doing anything else at the moment. I'm not removing satellite trails because that's basically a beta. I talked to Robin, who wrote SharpCap. Actually, some of the things that happened here in SharpCap are now because I mentioned them to him. Okay, especially in the auto-focusing system. So I think he took those suggestions and implemented them. We talked. So I haven't done anything else about banding suppression. I got to be careful. I mean, I've got it over here, and I don't know how that would actually how that would work. I haven't tried using it, to be honest with you. It'd be interesting to see how it works. I'd have to test it out. So, but that's a good idea. Thank you, Green Cat, for suggesting that. I usually process this banding out. And the flat field is causing not flat field, but the object is causing this down here that you see, because that's just the data, I believe. So, all right. So we have your thing here, Izabela. Now we're gonna get out of here and go to your next one that you asked for. But first, we're gonna go up to our night vision mode again. Okay, there's our night vision mode, and let's zoom in on this here. For those just getting here, this is the telescope control system. This is the telescope computer that you'll see pop on right now. And this is the telescope in the building, 2,500 miles away from here. This is some guy who thinks he's an astronomer. And this is the camera control and the main screen. Alright. Let's go to the next one that you asked for, which is the Poor Man's Double Cluster.
Poor Man's Double Cluster is exposure 25, gain 350, and stack 15 frames.
Okay, well, you'll be repeating that for me in just a moment.
Yeah.
You can see a telescope moving to it up there.
I'm sorry, excuse me a moment while you're getting set up.
All right. There it is, Izabela.
Any idea why it is called this funny name?
I think because it's not as rich as the regular double cluster.
Maybe.
Have you seen, the regular double cluster, right?
Oh yes, of course.
Yeah, that fills this much space because they're probably closer.
Mm-hmm.
But let's take a look here at what we can do. You wanted to do this for how long?
25 seconds.
25 seconds, and this will be a
350.
350. Okay, we're gonna
Yes.
go up by 50. All right, and then we'll drop out and stack this as well. Let's see what we got. And as we come into the stack, we'll see the last one that will clear. That's going to be really pretty. That's actually already up on the server by now, guys. Or did I neglect to mention, for those that don't know, all these images go up to a free server that you can download. You can go to SkyTourLive.com right there, or SkyTourLive.org. And you can go down and look for all of tonight's images. And it explains how to do it when you go to SkyTourLive.org and scroll down. It says, take me to some cool pictures, and you'll see them there. And any questions, let me know. All right, this is looking nice. Let's just darken up the background a little bit and color correct. There we go. Look at that. That's not a bad choice, Izabela. Yeah. And Izabela put the link up there for you. Thank you so much for doing that. Ray asked, did the desiccant on the camera get switched out? No. The entry gate was not working, so it has to be put off for another day. The maintenance guy is going to come out and fix the gate the next day or so. So it'll be next week when they get out there. And I've instructed them how to change out the desiccant, take the camera apart, and change out all the things they have to do, and to clean the sensor. So they're going to do that. All good. Wow, this is pretty. Zoom in.
Let me paste also the link to the Patreon, because all that we are doing tonight, everyone else can do, right?
That's right. That's right. This is right. We have a Patreon now, and the Patreon's available to the higher tier folks. Izabela won this. She won the higher tier free session with us because of the fact that she does so much work for us behind the scenes that this is my way of saying thank you in a way that is more meaningful, I think. She's telling us where to go.
This is my pleasure, Marc.
You're welcome.
I get a lot from it.
Green Cat says, are you using any filter on the camera? The answer is yes, we are, Green Cat. We are using a filter that is... It's like 3 narrowband filters in one. Okay, so we're getting our hydrogen alpha, we're getting our oxygen 3, and we're getting our sulfur 2, all combined in one filter, and then well, getting a little kick of luminance as well. So that filter that we're using is a 2-inch filter that's screwed into the camera itself. Right here behind me I have a filter wheel. And that filter wheel is going to have a dedicated hydrogen alpha, oxygen 3, sulfur 2 filter, followed by a radian narrowband filter for other work, followed by an open hole, so we can just do it without any filter if necessary. Like looking at the moon, we might not want a filter, but we could put a lunar filter in there or anything else. But it's a 5-place filter, and that'll be for telescope number 3. Telescope number 2 is behind me. It's been rehabbed and waiting to have the building rebuilt out here in Connecticut. And that building is, we're just waiting for the prices of wood to go down. COVID and the price crazy gouging and increases that occurred were just so ridiculous that we actually could not rebuild the building. We outgrew a dome. We had an actual dome out here. It was 50 feet away from here, maybe 65 feet, sorry. And that dome I sold because we outgrew it. It was an 8-foot dome. We outgrew it, so I sold it to a guy on Long Island, New York. He came, disassembled it himself, and took it away for almost the same price I paid for it new. So that's one thing. Second thing is we're going to do a bigger building, and I have a pop-top roof that I designed that's going to come off using linear actuators. It's literally going to lift up, slide back, and off. Okay, so it'll come up and down like a box top. pick up and move off to the side and down. I've tested the mechanism. It works fine. I have these linear actuators, which are like door closers on your door. They close the door softly. But imagine them having a motor in there so I can push the door open and pull the door closed. That's what these are. And I have 2 of them. Each one can lift 600 pounds. So it's a 1,200 total pound capability, lift capability. And the torque, the ability to push the roof off is, of course, very important. I talked to the engineers, and they kind of laughed and said, "You kidding me? You kind of have like the Rolls Royce of these actuators. I think they could lift a car." So, you know, as a jack, they certainly could. Anyway, pretty cool. Okay, Green Cat says, recently bought the Optolong L Enhance, but had not had a chance to... Optolong L Enhance, that's a very good filter. L, I believe, stands for luminance. And luminance is like a total light. But the Optolong filters have a good reputation anyway, so I have a feeling it's going to be good. So, not bad. Izabela, thank you for posting the Patreon.
Green Cat also asked you just above, are you using any filter on the camera?
Oh yeah, I answered that. That's what I answered.
Oh.
That's okay. Yeah, I told him I'm using the UHCS filter. I didn't give him the name though. It was just the sort of like the narrow bands all in one, so to speak. And that's pretty good. I think it's more akin to some of the other lines that we're pulling in. But as you can see, it really does make a difference. It makes a huge difference when you look at nebulae. Yeah, Patreon is very easy to use. I want to thank ERT Radio. He's one of our patrons. Thank you so much. It was very kind. Yep. Jeremy Blaine says, I should build you a magnetic motor for free power. That's one bill that could save you a ton of money. That could be true. I will say this observatory we're in now, that roof rolls on and off, and all electricity that we're using tonight was free. It's a green observatory completely, and all of our energy comes from the sun. It's stored in batteries during the day, and we're using the batteries at night when we do our observations. So that helps. Here in Connecticut, we don't have solar, so we are actually going to be using actual electrical service. And so that's for the 2 observatories. SkyTour 1, SkyTour LiveStream 1, STLS, is here in Connecticut. STLS 2, or STLS West, is this observatory we're witnessing tonight and enjoying tonight. And STLS 3 is on the way. We're actually studying sites elsewhere in Arizona. And long term, we're looking at going around the country with a mobile observatory, in addition to all these. And I don't know if any of you are familiar with a conference called Contact in the Desert, but I'm the Mutual UFO Network's chief photo and video analyst, and so I travel all over the world speaking about extraterrestrial life and so forth. And one of the things that I'm doing at Contact in the Desert is I'm doing a talk on potential propulsion that an alien spacecraft could use, using some advanced physics concepts that are broken down in layman's terms for everybody to understand. And then at night, I'm doing a SkyTour live stream live from Indian Wells, California, at the Contact in the Desert conference. It'll be very nice. Yeah. Ronald says, on the way, it sounds like you're pregnant. I am. I'm pregnant with telescope. You know? Yeah. Absolutely. Jeremy Blaine says, "I love magnetics. They are not used like they should be. No sun, no batteries." Well, I've looked at magnetic processes before. Studied it for years actually in physics, and unfortunately we don't get something for nothing. There's always a cost. There's always some kind of energy you have to put into the system, and that's the thing that I'd be very interested in finding. If anybody can crack that nut, that would be pretty cool. Open-minded about it, because clearly we know that there is a lot of current running through the ground courtesy of the sun. So why can't we use that, right? Solar flux hits the earth. Where does it go? It goes into the bedrock. It travels through the earth. Now, yes, it gets absorbed and it wanes and it goes down to very, very low voltages. But eventually, if we capture it and we capture enough of it with large enough detector surface area, we should be able to use it. Tesla thought we could. I think Nikola Tesla was great. We did a movie about Nikola Tesla a couple of years ago. Well, Izabela,
I remember that movie. What happened with it?
Oh, it came out, and unfortunately, Douglas Trumbull, the man that was a good friend of mine, he passed away. From a disease that just slowly eroded him. But we were very good friends, and so that movie came out. It's still out there somewhere. I've never seen the finished movie, and I probably never will. But it was said to be a very good movie. So,
What was the title of the movie?
I think it was like Imagination or something like that. I have to
Imagination.
look at. I don't remember. I have to ask his wife Julia. She'll remember.
Okay, I think I can find it.
Okay, we're at 28 here. We're gonna go to 29 on this, and then we're gonna stop. And
lab was right here in town.
That's correct. You're absolutely right.
Memorial Park.
Yeah. We recreated his lab in the studio.
I'm going to ask a question. Speaking of ground current and stuff, did you hear about everybody's buzzing now that it looks like the Earth's core is stopping spinning or changing direction or something? Have you heard about that?
Oh yeah, I've been dealing with that all day. Here's the thing: what people don't realize is that the Earth's core did this in the 60s. Okay, it's a 70-year cycle, and people don't really understand that it's a 70-year cycle, and so they think that it's something new. It's not new. The Earth's core has done this. It's spun down and then spun back up the other way. It's the thing that's happened. Like I said, it's cyclic, and what this did was it showed us some data points about what's going on with this. So that's really all it is. And I say all it is. There's a lot going on to that. Obviously, it's very, very complicated. But it was seismic studies that showed this. And I don't mean to diminish it as a scientific discovery. It's actually one of the most amazing discoveries ever, right? Because remember, the core of the Earth, the very central core, the inner core of the Earth, is solid. Okay, it's an iron nickel solid core. The outer core, all right, is this liquid iron nickel slurry, and together they rotate against each other. And by rotating against each other, they generate electrical currents, which manifest themselves as Earth's magnetic field. Okay, because electrical and magnetic fields are tied together. You can't have one without the other. So you could actually end up having a magnetic field of the Earth, which continues even though the cores change and change the rotation speeds, because it takes a long time for any of that stuff to manifest on the Earth. So if the Earth's core stops spinning, it's going to start going the other way. But it doesn't mean that the outer core isn't moving against it to continue those electrical currents. All right, it's just a way that I guess the geophysical arrangement is down there. I've never been to the core. I mean, I'd love to say I was at the core, but you know, I haven't been. You know, so it's pretty cool. Sorry about any lack of true numbers there, because I don't have the numbers on just how much it's slowing down and so forth. But I think they're saying it's going to slow to a stop and then go the other way.
That's just something about that. I mean, that's a whole lot of inertia right there.
Yeah.
Momentum, in other words.
Mm-hmm.
We'll all fly off into space.
Well, if Earth stopped, yes. But the Earth's core continues to rotate and do its thing separate from the rest of the planet. See, it's an inner ball moving separately from the rest of the planet around it. So
yeah, I know.
So I know that
we're all going to fly off into space.
Yeah, right. Well, if Earth stopped right now, we'd all hit the wall at 1,000 miles an hour. Thereabouts. People at the equator would get the worst of it. People at the northern extremes would probably not feel it as bad, but they'd still get whipped around. But they'd be on ice, so they'd slide forever. All right, Izabela, there's your poor man's double cluster. And I'm saving it now and saving it exactly as seen. And you can play with that and have fun with it as well.
All right. Thank you very much, Mark. This is the end of my time, which is way over 1 hour. And I appreciate it very much.
I go by the objects more than the time when it comes to this, and that's be the same thing for anyone else who joins our upper level tiers in Patreon. The tour is yours. If you know what you're doing, you can take a tour anywhere you want to go, and that would happen after the second consecutive payment for the upper tiers. For that, just so you know. So that's all good. But Izabela, I want to thank you for joining us tonight. That was very good of you to come along, and I'm glad you could take advantage of this. And we will check back in with you in in a few minutes as we move our way through all this and do some more.
For another one.
Okay, I'm sorry that I wasn't very active this time, but sometime in the future I won't stop talking. I won't let you talk. So.
Oh, well, that's just fine.
So please, people, consider becoming a patron on the Patreon, because this channel deserves this. This is the best channel for astronomy, life astronomy, and we all love it. We all feel it like a home. So this channel deserves a little bit of help, a little bit of to give a shoulder. So.
Well, thank you so much. That's very kind.
Boogeyman.
And see you in the chat. I'm still here. Yeah. Signing out, Izabela. Signing out.
All right, Izabela.
Adios,
thank you very much. Okay.
Bye,
see you later. Bye-bye. All right. So you're still with me, Daryl. So
you're stuck with me now.
That's okay. I've been stuck with you for a long time with the SkyTour LiveStream. I don't mind.
Hey.
All right. I was gonna go with the Boogeyman, but you know, I really want to do stop it. I'm gonna do something else. I actually wanted to do the Casper the Friendly Ghost Nebula with some changes.
All right.
I gotta see if it's gonna be visible. So watch the telescope, see if it's gonna be impacting the wall. I don't think so, because we're pretty high right now.
That way.
There it is. Yeah. All right, so knowing how this is laid out, I am going to move us a little bit to the west. Sorry, I totally meant east.
The other west.
The other west, yeah. Anti-west. Negative west. That's good. And we'll just drop down a little bit. And go to the east a little more. Because in this shot, we're going to capture part of Barnard's Loop as well, which is over here. You can almost see a little bit of the red for Barnard's Loop starting to impact over there. We'll go here. This is good. All right, so we're searching for our guide star, and then we're going to do a, I'll say 55-second shot. All right, and we're guiding. I'll wait for it to stabilize. Once again, folks, show Izabela your love. Thank you, Izabela, for coming on board to do that. That's very nice. You earned it. Ronald, you're next. Ronald also has a SkyTour coming up. He's been doing some stuff for us in the background as well. So put together some ideas, Ronald, because you're going to get yourself a SkyTour out of us for your help to us. All right? He knows. I'm just reminding him. Hey there, Uber Crew and D Smith. How are you guys doing? That was nice of you, thanking Izabela for that. And Robin Curtis says hello. Robin Curtis, how are you? Okay, we're ready here. We're going to go 55 seconds on this, which is the Casper, the Friendly Ghost Nebula, also known as Measure 78. So we'll clear the previous one. And then I shall put M78 up here, which is a reflection nebula. All right. No. Let me prepare this for you. Okay, so here's what we're doing right here. We're doing this guy.
Cindy, I liked hearing her dog Sky, too.
Yeah, that's true. Okay, let's do a little processing on this first frame. Yeah, see, we got an awful lot of interesting nebula in here, and we're at 40%. So let's drop down a little bit more. And there you can see over to the left, you can see Barnard's Loop, which is this large, arcing, red, ancient supernova remnant. And you can see this beautiful reflection nebula and dark nebula, which courses down through here. And you can see it's got some filamentary structure, which actually will become very clear soon. Very, very shortly, you'll start to see that much clearer. Wow, this is going to be nice. It's up pretty high as well. So let's take this, move it back a little bit.
Casper and the Boogeyman are basically right next to each other in the sky, are they not?
They are, actually, and I can't remember if it's up there or down there, but it's actually, well, we can look, right, while we're doing this.
I would wonder if it would be worth trying to...
Mosaic?
Yes.
Yeah,
I assume the dark nebulosity we see in both of them is probably, part of the same complex.
I imagine it's related, yeah.
And I know that page I sent you about the Boogeyman the other night talked like Barnard's Loop is near or behind the Boogeyman also.
Yeah. No, we're talking about the Boogeyman. That's actually Lindstark Nebula 1622. That's going to be this guy here. LDN 1622. And relative to where the where we are, that's a little too... Well, that might be just fine, actually. See, we're here right now, and we want to go there.
You see Barnard's Loop running between the two, actually.
Yeah. So it's right on the other side here.
Yeah.
It's actually to the up there. It's up there. So let's see. I wonder if because we're centered on this right now. We're right about here. Okay, just about there. So we would have to go up one whole field, and then over one whole field, and then go down one whole field to make a 4 separate exposures, 4 exposures of 55 seconds each, and then do a stack. And we'll catch NGC 2112. Maybe that'd be fun. Maybe we can do that.
Sometime. Just a thought.
Yeah, no, it's a good idea. I mean, we could just go right from here to there, and they'll overlap at the corners. Oh, that's very interesting satellite. Look at that. That's a tumbling rocket body is what it is. It's slowly tumbling. We can actually calculate its roll rate just by looking at the length of its value. From here to here is the... well, I want to zoom in first. Okay, so if we come in here, you can see that there's a slight delay before the next exposure starts. So it goes from here to here. See that? So in that time, which is 55 seconds, we can actually divide this and figure out where along the length it gets its brightest. And from this gradual increase to the dimming across this exposure down to here, to get it to the same level, we can actually come up with a curve that would show you the roll rate, the rolling frequency of this satellite body, this rocket body.
Looks like it's quite slow.
Yeah, it looks like it's in 55 seconds. It's kind of going, it's rotating at some... Look at this beautiful... God, it's rotating pretty slowly, yes. Look at this. Now look at this detail, guys. See how this detail's coming in really beautifully now? Now you see why I kind of put it there, so you could get all this down here. Yeah, it's really nice. Wow. Let's see what else is here. Let's give it a shot. Yeah, look at all that. All that you see is dust and emission nebula. Diffuse. It's called diffuse nebula. Wow, just beautiful. Let's do it without the shotgun approach. That's really pretty. Wow.
Sinuous.
Yeah, look at that. Let's zoom in on that for a minute. Let's check that out. Okay, that's good. Look at the complexity in here. Look at the complexity moving through. This is just beautifully complex. Yeah. So again, this is Casper, the friendly ghost, known as Messier 78. It's a reflection nebula, which we know means it's just a dust grains that are scattering starlight from these stars right here. These stars, like we see one right here, another one right here. Okay, there's one up here. So that's what's causing all this to happen right now. That's what's making it happen. And I really, really do love this beautiful sinuous looking stuff right here. Look at how it goes down here, comes around the corner, down here, up here, and back to there. Look at that. That's just a beautiful thing. Let me pull this out of the for now. Yeah, look at that. Amazing. Excuse me. All right. Wow. This is something else, man. I think after this, I want to go up there and grab the Boogeyman and see if we can get a mosaic and then fill in at another time. We'll see if it'll match, okay?
Sure.
I've said this before, guys. You look here, and you're looking at what I think is the seat of life in the universe. Seat, S-E-A-T, and seed, S-E-E-D, of life. It's both. And these dark nebulae are the places where life and stars will form. It happened here, okay? Before the sun formed in a nebula, that was a dark nebula. And after the dark nebula was formed, after the dark nebula was formed, the sun formed in it and lit it up. And I think that's pretty cool. Very beautiful.
Kind of a pity that rocket body had to step on the image.
Actually, it sort of adds something to this particular image, you know?
Yeah, maybe. Or just the general idea of, we've talked about before.
Yeah.
Getting to the point where you can't avoid him anymore. Seems to be, especially when you're in this part of the sky.
Yeah, especially if we're in Orion. I cannot take a picture of the Orion Nebula Complex without having 3 satellites in there. I'm thinking I have to look at the geostationary satellite speeds that I might expect and see if those are actually geostationary satellites in Orion. You mentioned it the other night as a possibility, and I wasn't sure, so I couldn't say yes or no, but it's possible. Do you remember that?
Yes, I remember.
Okay. Wow, look at that. This is only 11. There's only 11 stacked images, and look at this. I like this right here, this area right here. It's got these little spots. Are these voids by collapsing objects in here, possibly? Who knows? Are we going to see 4 stars here someday? Who knows?
Make you wonder.
Yeah, it does. Man, that's pretty. All right, let's do this. So this gives you a little softer look, right? And so it's not as harsh. Yeah, this is a more subtle look at it. Look at that. That's just nice. Wow. We could actually bring this. If we bring this closer, it's gonna raise that brightness a little bit. That's something, And now if I turn on the unsharp mask now. Okay, now all this detail is punched up and you can see it. And that's only on the image that we save exactly as seen. It's not on the actual data. The actual data is soft and barely visible, and we have to process to bring that information out. Another satellite there.
Right where your mouse was, to the lower right, that right there. Can you zoom in on that?
Yeah. It's a emission nebula segment. I'm not sure if it's what kind of object that is there, but I think that maybe that's a T-Tauri type star. Who knows? We have to check it out. I'm not sure.
That's what it reminded me of. You see,
I'm
it
gonna shut
actually
off
looks
our
like a
enhancements.
star in a semicircle or almost a whole circle there.
Yeah, this looks to me like this star might be causing that, and this is a continuation of it, but this is blocking it. He's talking about this area right here. And this star. And that semicircle.
There's a star inside that semicircle.
It might be a star. It might also be just more nebula with more dark nebula blocking it. I can't really tell. But you could be right. You could be right. Either way, I know that this is a really interesting area.
There's a very red star over to the right of that, too.
I mean, this one?
Yes.
Yeah.
Oh, the whole area just...
It just pops.
I said before, the sinuous nature of the dark nebulosity.
Yeah.
When you get up toward the bright part up there, toward the top, the dark clouds kind of semi-detached from the main arc and all that.
Mm-hmm.
Very red star there, too.
Up here, you mean?
Right near your pointer, where you were a moment ago.
Right there?
Yes.
Yeah, that star may be in the dust, and so it's reddened.
And then the whole dark shape above that kind of reminds me of sort of like a little seahorse shape there.
It does, doesn't it? And it's actually, it looks like it's got a swept motion to it, like maybe these stars are pushing that dust. If we can think of it that way, I'm not sure. This is neat, because if you notice, it looks like a sweeping set of material with these, what looks like reddened stars in here. Dust reddened stars. And this material sweeping over the nebula. Yet if you were there, you wouldn't even notice any of this. You wouldn't even know you were in this if you were there.
Oh, there's so much going on there.
Yeah. Let's go and do a color correction one more time here. There we go. Okay, we've done 17 55-second frames. Guiding is impeccable, which is wonderful. I actually spent weeks working privately on the scope, trying to get the guiding right, learning how it works to the point where I could literally figure everything out about it if I had to, and I'm glad I did.
You evidently have it dialed in.
Hopefully. And just think, I'll have to do it all over again for the next telescope. Which is fine.
Learning curve.
I don't mind. I do not mind. Look at this. This is just so beautiful and subtle, and it's just stunning.
Can you get rid of that satellite trail if you do a processed image?
Yep. I mean, down here, let me show you something, okay? Down here, I have a remove satellite trails. The trouble is, it's not it's beta, so it's not as reliable.
Yeah, I remember you mentioned that earlier.
So if I say remove right now, yeah, use test first. Okay, let's do that. I don't want to play with it on such a good image.
Yeah, well,
Yeah,
worry about
I don't want to. I don't want to do it now. I mean, I'll try it later. All right, very nice. So you guys having a good time so far? How could you not? We're seeing Casper, the friendly ghost, measure 78. We're gonna go to 20 images of this, and then we will move on to the Boogeyman. The Boogeyman. El Boogo. All right, here we go. All right, so we'll pause it here. We have it labeled as M78RN, and we'll save. That's our FITS file, and then save exactly as seen. And yes, Izabela, you can take this and process it too, of course. You're all welcome to process these images because I'm giving you the raws, the raw images, and the one that you see exactly as seen. You have less processing you can do on the PNG files, but by far. But the FITS files are the ones you'd want to learn how to process.
excuse me again for just a moment.
Alrighty, I'll be on the Boogeyman by the time you get back. Oh, this is beautiful. Wow, look at that. Holy cow, that's just incredible. Alright. Let's pull that out. We don't need that. Alright, and we're going to go back to our 1 second timing with see, did it again. We'll go to our 1 second timing with our night vision mode. Yes, that's what I want. All right. Okay. There we go. All right. So back now to our planetarium, and then we're going to look for the LDN 1622 Lindsdark Nebula, which is right to the upper left. So that's where we are now, and now we're going to come here. So go, go, go. You don't watch the telescope go that way now. Zip, up and over. Yeah. And okay. All right. I think we want to move a little east, a tiny bit. That's what I'm thinking right now. We're going to move east a little bit and get in there right now. Okay, here we go. Let's now go in here and set this again for 55 seconds at 350.
Okay.
All right. There we go. I think it's close. If it's not directly on here, we'll get it. And the previous one was just stunning. I mean, look at this one more time. What a shot. Wow.
That's great.
It's really pretty. All that detail is going to come out Look at it all the way down. Wow. All right. Well, we're going to clear this now because it's up on the server already. And we have 10 seconds left in this exposure. And then after the 10-second mark, we'll see the first shot of the Boogeyman. The Boogeyman. Here we go. Oh, look at that. There it is. But I think we may have to... I think I may have to move it down a little. Oh, maybe not. Oh, we're good. Nice. So let's zoom out. There's our satellite. Another satellite with a tumbling body. And a definite tumbler right there. Look at that.
That up one, the same one we saw in the other picture.
Well, we went way up, so I don't think that's it.
Okay.
But
Yeah,
this one...
You have two of them there.
Yeah, look at this one. Look at that. Oh, there's a... That's a fairly rapid spinning satellite. All right. Oh, this is really something. This is looking. This looks ominous. The colors are pretty already. This is the Boogeyman. So.
Interesting, you'd have the Boogeyman and a friendly ghost right next to each other.
I know, right? All right, let's see if we can do this. And let's set the colors. Color correction. Really nice. This right here is the Barnard's Loop. We're on the other side of it. The Barnard's Loop is a giant arc through Orion, and the Boogeyman is on this side, and Casper the Friendly Ghost is on that side, with the arc separating them. And that arc is the remnant of an old supernova that it went off in this region. Wow.
I just thought the dark nebulosity in both this and the Casper image are, you know, they look similar, almost like, you know, they're part of the same thing.
Yeah. That's true. Wow. Boy, oh boy. Let's see if anyone has any questions out here in the chat. I don't see any questions. I see a lot of compliments. That's nice. Yep. Isabel says, now that I'm not there, Mark can put whatever settings he wants. Well, look, if your settings were settings that weren't going to guarantee you some success, I would have told you. But you've been here long enough to know what might work, and you actually do a good job. So there. You picked some good settings. Okay. Looking all good already. Look at this. Look at this. It's looking really good. You know? This is only 5 stack. Let's see what else is there. Look what else is there. this is a real push, you know. Look, we got satellites coming in this way, satellites going that way, satellite going that way. 1, 2, 3, actually more than one this way. I prefer this so I don't see them. But we can bring this in here. And new, more precise adjustments. Wow. See, and the longer we do this, of course, the more the satellite trails just get automatically wiped away. You know, and that's because the stack process that we're doing. And for those that may not know what we're doing, we're stacking images together, right? We take one, we align it with the next, and stack them on top of each other. And we do that, make an image sandwich. And as you keep adding data and data and data, whether it's dark cloud data or bright star data, the data comes to the top and becomes the most dominant thing. So all the noise that's inside ends up getting minimized. And you don't have a whole lot of noise. You just end up having the data. And that's why the longer you go, the more data comes out and the better it starts to look. Wow, that's nice.
Look like when you can see those other satellite trails. There was that one coming from upper right headed toward lower left.
Yeah.
Looked like it was tumbling too.
This one? It was there?
Yeah, it was also a series of dots close together.
Yeah. Okay. So this is the Boogeyman, known as LDN 1622, Lyn's Dark Nebula. And Lyn's Dark Nebula, of course, comes from Lyn's Dark Nebula catalog. And I said Dark Nebula with Reflection Nebula because of this right here, this little guy right there. That's a little Reflection Nebula. Okay, so, you know, the Reflection Nebula is here, the Dark Nebula is all here. Okay? All this red here, this diffuse red here, this is Emission Nebula. Okay, this specifically. And that is, diffuse red hydrogen that's been ionized by hot stars in the area. And it looks like, for the first time, I've never seen this, but we're getting some rather interesting detail in here. See that, Darrow?
Oh, yeah. Well, that looks sort of semi-illuminated itself.
It does.
Of the grayer areas.
Yeah.
Makes you wonder which star is doing that.
Yeah.
I'd want to say it's the big red one there on the right, but that could just be a foreground object. And
I agree. Which one is it? That's the question.
Several likely candidates in there.
Yeah. Wow.
And you can see in that Reflection Nebula, looks like there's a little swirl and a curl in there.
Like this guy right here.
Yep.
Yeah, I wonder if that's just, let's zoom way in on that. It won't support zooming way in. But, it looks like that's actually some just dark nebula in here that's...
Yeah.
Yeah, that's interesting.
Like a cinnamon roll.
Yeah.
It looks like it's really there. It's kind of a spiral shape to it.
Yeah, it's true. 11 stacks so far.
How many did you do on Casper?
I did, I forget, but it's okay. If you look on if you go on the database or the data server,
Doing it right.
just divide the divide the total time by the frames, and you get the time of each frame.
20 frames, 1100 seconds.
Okay, 1100 divided by 20 is your answer.
55.
You got it.
Yep.
So I'm doing 55 here as well.
Yep.
Look at how nice and detailed. I'm gonna try and do this.
We just want to try to make this similar to Casper, you know, do it 20 frames also.
Yeah. I believe it's really performing well tonight. Let's move you in.
Michael Hedrick has a question for you.
Okay. Hang on, Mike. I'll be right with you. All right, let's move in this guy.
Hello, Tom.
Hey, Papa Tom, what's up? How much snow can the observatory... Well, it's not a dome. Actually, it's a flat, a sloped roof out in Arizona. Out here, it's going to be a sloped roof as well, but smaller than the Arizona size. Arizona's size is 11 by 11 feet, and this one out here is going to be like 8 or 9 by 9. And the roof structure is going to be somewhere in the neighborhood of about a total of 175 pounds for the roof, maybe 200 pounds at the most. And I have the 2 linear actuators, which can each lift 600 pounds. And they will, let me pull that out. And they will actually be able to lift snowpack on that roof and literally pour it off. That's the goal and the plan.
You know, his question reminds me, though. I looked at Wendy this morning, satellite image, and there was snow just to the north of you, and it was covering about it was kind of, the farther east it got, the farther south it went, but looked like it was covered almost half the state of Arizona.
Mm. There's very little snow out here where this Arizona Desert Telescope is.
Yeah, well, there's that, like a thermocline or something up north of you, where the climate changes, and you can see a really sharp demarcation from the upper left down to the lower right part of the state.
From desert, okay, to snow. Keep in mind that Arizona's on a slope. We're like here, and it goes all the way to 8,000 feet up there. Yeah. 8,000 foot skies are beautiful, but not as clear up there. So, you know, I'd rather have 300 clear nights like this with this kind of shot than 150 nights of slightly better skies.
Well, that's where Lowell built his observatory.
Lowell put it there at a time when the climate was different. Climate was different back then. Climate was different at Mount Palomar too, the Hale telescope.
Light pollution was different too.
Well, yeah.
Palomar.
Yeah. Although, I checked the dark sky for Palomar. It's actually in a semi-dark sky zone right now. You'd think it's in the middle of a city. It's not. It's actually, Palomar Mountain is actually pretty isolated from everything else. It's nice. I didn't realize that. Alright, let's see here. Oh yeah, look at that.
It's nice.
Yeah. Wow. I love watching this develop. I don't mind telling you. Yeah.
As you look at the dark blobs higher up to the upper left,
Yes.
there's that one there. It's got a line sticking out pointing to the upper left, pointing right at that dark cloud all by itself out there farthest to the upper left.
You're talking about these guys.
Yes. And there's like
Okay.
there's a very faint trail leading back from the one farthest to the upper left, back toward the direction of that one that's pointing toward it.
Yeah, you're talking about this right here.
Yeah, and then just to the right of that, yes.
Yep. There is a faint trail. You can see that.
Yeah.
Let's see if we can actually bring that out. First of all, let's zoom in on it a little bit, and it'll become more obvious anyway. Yeah, you can see it there.
Michael, not me.
Let's do this. What did he say?
By the way, have either of you ever been to Keck Telescope?
Oh, I've never been to Keck.
That's Hawaii, right?
You don't have to use oxygen, but you know what? I guess when you're first there, you may have to take a few whiffs, because you're at 13,790 feet Mauna Kea, and so you do have to consider that you're going to be a little short of breath, and you'll need to have like time to acclimate for a couple days if you're going to work there at all. I'd like to go. I'd like to talk to some folks up there, see if I can get in and spend some time there. I have friends, I'm sure, that I know that have been there, working. So
I have a water bottle from there.
you told me that.
Yeah.
And
Really nice blue Nalgene bottle. My boss married a Hawaiian girl, and they were over there visiting, and he went to the visitor center or someplace.
Okay.
Picked that up for me. It was nice of him.
Well, it was very nice of Wayne Pinkham, who is also a SkyTour listener, to go to Mauna Kea, and he brought me back an excellent T-shirt, which has on the back every mirror on the mountain, represented by a circle with hexagonal segments and all that stuff where necessary, like the Gemini system. And it's really cool. Very, very nice shirt. Probably the best T-shirt anyone's ever given me. So I say, hats off to that. Wayne was really above and beyond. That was fun. All right, so now let's do this. Look at all the detail now, and I can see even more in here. See that?
Yep. You're at 20 images.
I know. I'm gonna do a little more.
It's really something.
It is. Let's try this. Let's see what this wants to do. See, that's where it wants to go, and I think that it deserves more detail. Look at that. Let's back out for it. Look at that. Look at how the lighter gray on this. You see how we're catching the two-toned dark dust out in the middle of space?
Yeah.
Look at the puffs here, puffs of cloud. We're getting a lot more detail here than we've ever gotten before. This is really quite a spectacular
And they're just
image.
where your pointer just was, there was a fine line of dark nebulosity there running down to the left.
You talking here?
Below that.
You talking about this?
Nope, a little farther down.
You talking about
right there.
this?
Yeah, that's a fine dark line there. Especially
It is.
upper
Yep.
part.
That's nice. Okay. We're going to go to 23 images and then we'll stop. And go to the next item. Very nice. Hey Hunter, how you doing? All right. My son just got home from work. He works at the biggest television station in the state. He's moved from 3 a.m. to 11 a.m. shift to 3 p.m. to midnight shift.
Prime time.
Oh yeah, I mean he's been on scenes of shootings and all kinds of things. He's a cameraman. But he seems to have a response time and capability that is really interesting on the job. So they're giving him some cool opportunities. I love this. This is beautiful. I said I was going to stop it at 23, and I lied. I think we're going to go to 25. Because these clouds, I want to see them in more detail. This is going to be beautiful. And like you zoom in, you can see the noise that every sensor has on all over the world. For any astronomical work you do, you're going to see noise. And so you see this as modeled color. I can get rid of all that. And I will. I'll get rid of all that. Notice the stars are nice and round. We want that. And focused. We want that. That's just something. Look at the subtlety in this stuff is amazing. It's almost like this comes out now and it looks like this one's like over the edge of the cliff. You know, this is resting on the sand. This was over the edge of the cliff. Oh, out in the middle of nowhere.
Cloud there we called the hummingbird.
Oh, this guy here? Where the head and the beak and then the wings?
Yes.
Yep. That's Daryl's hummingbird segment right there, guys. Nice. Okay. I still lied to you. Now it's 26. Okay. Let's stop there. Okay, I'm going to change the name. And this is Boogeyman. It's called LDN 1622. Lynn's Dark Nebula. And we will save it. Really came out nice. That's the nicest one we've done. Yes, sir. Alright, so now we're in such a region of immense beauty that I would like to take us now into want to go to the Rosette? It's such a beautiful night. I'm going to go to the Rosette.
Sounds like.
Alright, here we go. Rosette. Now, first things first, let's get rid of the stack. And we'll go back to our 1 second pick here for our night vision mode. In night vision mode we go. There we are. Come back here. Go to the Rosette. Off you go. This is such a showpiece. Such a showpiece. There it is. Really beautiful showpiece. Alright. That looks pretty good. Just a little jog to the left. To the east. Yeah. All right. So we'll let the guide catch us a nice guide star. I did a private stream last night. I did a long mosaic of the whole Orion area. And I discovered that right around this time of the night, there was some desert winds that kicked up and was starting to vibrate the telescope, so I couldn't do it. I couldn't finish it. I did finish it, but I could not get a good registration for the last one, but that's okay. All right. This is a bright nebula, so we don't have to go that long. So we'll go 40 seconds. Alright. And then get out of night vision mode, jump into our live stack, take one last look at the Boogeyman. Wow, that just came out so beautiful. Yeah. It looks finished process now, and we haven't even started. Okay. Alright. So let's give this a shot here. So watch this, guys. Check out in the next 12 seconds, you're going to see the Rosette Nebula. I think we need to be prepared to show it in its glory. Look at that. So what I'm getting at is we're going to do this. Yeah, we're going to get rid of the telescope here for a minute. There we go. And move it over. Look at that. Let me zoom in, make sure that I didn't jump the gun on the exposure. I did a little bit. Okay. I'm going to clear it and let this next exposure take over, because it'll be a better one.
Is the temperature comp still off?
No, it's on. But the temperature comp is just an equation, a suggestion. So checking the focus, if we still need to focus again, we will. Yes, Ray, the time is off and I can't fix it right now. Okay. So here we go. Here's the next one. There we go. That's pretty. Focus looks okay. Let's color correct. Wow, that's really bright. That's really beautiful. We'll zoom out. Outstanding. Hello, Rose. Rose looks pretty. Young hot cluster in the middle of this nebula, formed in this nebula, and the stellar winds from this hot young cluster literally cleared a cavity around the stars, as you can see. And that's what that hole is. It's the cavity cleared by the hot young star's stellar winds, pushing gas and dust away, leaving a relative opening around the cluster. That's what all clusters do. As they are formed, they will push away gas and dust around them. So it's like they're basically leaving the womb, so to speak, and then clearing the way for their continued movement around the galaxy eventually, which is kind of weird, but that's kind of how you can think about it. But they're not obviously alive unless you subscribe to the Gaia hypothesis. Let's pull this in. Oh my gosh, look at that. Now up here, I'm going to show you these up here. These come in pretty quickly, so we can show them pretty well. See the tendrils of black material here? These tendrils are obviously dust streaks, right? But these dust tendrils are these micron-sized dust particles, which is really small, and then we also see these blobs, little tiny dark dots, every now and then. These dark dots that you see in the nebulae that we always look at like this, these dark dust blobs are actually self-gravitationally condensing dust that may form a star, and possibly a star with planets at some point. Okay, we see lots of them when we look in this nebula. You know, there's lots of them here. You know, there's some here. Okay, there's some on this side over here. Okay, right, and we also see pillars. We also, I guess I can see we're getting some wind out there because these images are a little elongated. So this is about the time I mentioned we get wind. Go figure. So we might not get as much going on. Might not get to go too much further. Let's do an acquisition on our AllSky camera and see if we have a clear night. The moon.
There
What?
looks a little cloudy there at the southwest.
We're going to find out right now.
Oh, that's an old picture.
It is.
Jupiter's down now.
Yep. And the moon is set. And this, we have a sensitive camera. This is the east. This is the lights of Phoenix, 65 miles away. And obviously this is a dark nebula. No. This is bird turd. And this is also bird poop. There's the winter Milky Way. There's Orion. Okay, there's the Hyades. There's Mars. There's the Pleiades. Way up here is the W of Cassiopeia. Way up in the northeast.
Northwest.
Yeah, that's right. That's right, northwest. And then on this side we have next to here we have, this is Capella and Auriga, Gemini twins, Castor and Pollux. Right there is Messier 35, that beautiful cluster with 2178 right near it. This is Sirius, the brightest star in the sky, and this is Procyon, Orion's two hunting dogs.
Dog and
So, huh?
The big dog and the little dog.
Yep, that's right. Okay. Yeah, we're getting some wind, as you can see. So what I want to try and do is I want to get a good shot. So I'm gonna clear this, and we're gonna wait for this next one to come in and see if the wind has calmed down a little bit. Yeah, Ray, we can't see the comet yet. Okay. As you can see now, these stars look much better than what we just saw. So let's let this come in. Do a couple more. There's a satellite right behind me. Right there. See it right there?
When you zoom in on the little skinny tendrils up above the star cluster,
Yeah.
you can look at some of them, and there was one little one that had a star at each end of it, and there's a bigger one that has a star at each end that looks almost like a pair of pliers or something.
Okay. And we're getting affected by wind still. Okay.
That little one right there where your pointer is. See that?
This one?
Yeah, there's a star in each end of that little oblong cloud.
Over here?
Because they may be, foreground, but it sure looks like it. And
Yeah, it could be background too. Line of sight.
then the bigger one to the left there.
We got like this.
Yeah.
Yeah.
The
It's like a Y.
star of that top one, and then there at the bottom looks almost like a pair of pliers or a crescent wrench with a
Right here?
star. Yes, with a star in the middle of it.
Right there, yeah. Yep.
Thank you, Izabela. That is something.
So here you go. This is where we are right now at the Rosette Nebula. It's a stellar nursery. Oh yes, thank you. Izabela, you got in just in time. The wind has picked up out there, so I can't guarantee how good any of our exposures are going to look moving forward here. But it's okay. We have a lot of fun anyway. Remember, SkyTourLive.com, if you want to know where those pictures are. If you missed those links that Izabela's putting in, go here and scroll down, and you can find your way. In fact, while we're doing this, here we go. So let's do this. So here's SkyTour live.org, SkyTourLive.com. If you want to go to SkyTour LiveStream, okay, that's here. That's our stream where we are currently live. All right, and if you prefer to go to our Patreon, you can go to our Patreon page and select the membership level and become a patron if you want. And if you just scroll down, you say, I want cool pictures. Well, then you go to the online database, all right, and you just click this. Let me pull this away so you can see that, right? So if we say I want to go to the online database, that's simple. Watch your eyes, right? Okay. So here's our online database. Notice the dates. These are date folders. 124, that was yesterday evening, okay? It's after midnight here, so it's the 25th here in Connecticut. And the Boogeyman, which Izabela just linked to, you scroll down. Okay, first of all, let's go back. You click on Boogeyman, LDN 1622, and it takes you here, and you go, well, wait, what's that? That's the time, 9:42:40. We're using military time. And you click one more time, and now you can see that there's a picture inside this folder. And this right here, 16 bits, 26 frames, that's the raw file that you can take and process, or you can just click in here and check this out, and bam, look at that. You get the picture that we just took moments ago. All right? So this is how you use this. So that's how our process works. You can scroll down some more and get photographic prints. You can check out our photo gallery. You can learn about us. You can even do more, and you can see we actually have a physical address, and we're on Facebook, we're on Instagram, Twitter, and YouTube. So we're all over the place. So there you go. That's what we are. And so that said, that gives you a good idea. And where are we now with this? This isn't looking bad. That's looking okay. Wow, look at that, huh? Let's see what we've got here for a stack. I have two monitors, by the way, so you'll see me looking both ways. This is my data monitor feed from the observatory. This is the broadcast software. So I look at both. Right, but I'm seeing the same image each side. Okay. We got 9. We're going to go to 10 on this because it doesn't need much. Yeah, really pretty. So there's 10. So we're going to pause it. And we're going to change the name up here to Rosette Nebula. Yeah, Rosette Nebula. And say save it. And save exactly as seen. Here we go. So it's up there now, and we're gonna pop out of this now and go back to our night vision mode. All right. And let's also bring back the telescope. Okay. All right, good. So I would like to take us someplace else that we have not been to. This guy.
Poison arrow, that's all dependent on the weather.
Yeah, I mean, technically we're supposed to have about 300 clear nights a year out there. And on occasion we do. Actually, is it the owl that's here? No.
The owl's up in
Yeah, Ursa Major area. What? There is a wonderful little planetary in Gemini, and I can't think of its name.
Eskimo.
Yes, Eskimo. All right, let's look at the Eskimo. Yeah, I think it's... Look, there's an Eskimo's Wife Nebula. That's funny. There's the Eskimo right there. Okay, we're going to go there. Eskimo was smaller, but it's really interesting.
It is pretty small. The guy from the club that had the weird, funky 13-inch Dobsonian,
Yeah.
he had the Eskimo one night. It was some ridiculous magnification. I want to say it was like 800 power or something.
Okay.
amazing how well he grabbed it.
There it is. Okay. We're going to move west a little bit. This is a planetary nebula. It's the end state of a star. And inside is just a white dwarf. So let's see if we can capture it by zooming in and altering our there we go. We're going to alter our gain. There we go. Interesting. So this down to zero gain, and so let's try to see what a 700 millisecond shot looks like in a stack. Now it won't come in right away because we have to clear the previous one. There we go. But there it is. And now let's see. Try and pull out some data and make it look good. Yeah, okay. Get rid of this too.
Pink.
Well, not really. Okay, I go here. Really interesting. Okay, there we go.
Yes, Ray. It's one that might benefit from focal length. Looks really cool when you can get in on it. It looks like an Eskimo wearing a parka. And he has, you know, that fur lining around the opening for his face and the hood.
Let's see. I'm gonna take us up a little higher and clear it. Let's try and do this here.
Excuse me.
Yeah, we're not gonna get more out of it tonight.
Yeah.
I wanted to see. All right, so that's still interesting. The green is always pretty.
Yeah. Oxygen 3.
That's right. All right. Now let's see. We can go here. Actually, we've done that. I'm gonna actually. I'm gonna go to. We're gonna go with the Spider Nebula and do a deep dive on the Spider Nebula. Okay. I think this is the Fly. All right, so let's do 45 seconds on this. Okay, and now I'm going to clear that.
Ray mentioned something interesting about the Eskimo. At the center of NGC 2392, there is an O-type star, spectral type of O, parentheses H6F. I wouldn't expect a O star in the middle of planetary nebula. I wonder if this is one of those cases where it's
Wolf-Rayet?
yeah.
If that information is correct, then it's not a white dwarf. It's definitely going to be most likely a Wolf-Rayet. Okay.
Well, at one point the article says
Maybe the progenitor. No, that would have been a supernova.
says that it is surrounded by gas that compose the outer layers of a sun-like star.
Yeah, that's not an O star.
Right, but then at the center of NGC 2392, there is an O-type star, spectral type of OH6F.
Okay, well, there's some information in there that's incorrect. Because it would be a sun-like star. That means it's only a massive, like about a sun-like star.
Right.
It's certainly not an O-type star, so that information is wrong.
Well, that's why I brought this up.
Yeah. If you're seeing a planetary nebula that's truly a planetary nebula, then it's a white dwarf in the center. Now, technically, the temperature of the white dwarf could be the temperature of an O-type star. Actually, and maybe that's what they're talking about. I don't know.
Well,
Maybe that's the mistaken verbiage.
this is what we've talked before about when we've talked about Wolf-Rayet stars, that some of them are classified as planetary nebulas.
Correct, but if the Eskimo Nebula is a Wolf-Rayet star nebula, then saying it's a sun-like star was incorrect.
I understand. That's why I bring
Yeah.
all this up, though.
Yeah. Oh, yeah. Okay, this is called the spider because it has these tendrils sticking out in all directions. It kind of looks like a very interesting spider of sorts from your nightmares. Let's throw this out there for a second. Spider and Fly, Stellar Industries, Mission Nebula. So this is the spider over here. And the Fly is over here with his big beady eyes. We're gonna wait for this to develop here. We've got 6 frames stacked so far. Looking good. Yeah, Ray's just taking stuff from Wikipedia and putting it in here.
Yes, I know.
If there's an O-type star in there, it has nothing to do with the nebula. And it's probably, if they're talking about an actual O-type star, it's either a mistake or it's there and it's a separate thing from the white dwarf that's in there.
Yeah, let me go back and look again. I closed it.
Let's get this. Let's play with this one now for a while.
They don't expand on that.
Yeah, I think that Wikipedia is known for not being correct. You can't.
Yeah, I know that.
Especially with technical stuff, unless unless you're really well versed and know the phenomena, you might not pick out the errors, right? But if there's an O-type star there, then we would be able to know it by its spectral lines, the strong helium lines or whatever. But if not, well, I don't know. But we'll have to see. Hey, Greg O'Brien, how you doing? Let's remove that from there. Louis T is with us. Hey, Louis T, how you doing? Good to see you, Louis.
Interestingly, the IAU Working Group on Star Names discontinued the use of the name Eskimo Nebula and Clownface Nebula as offensive.
Okay.
Strongly recommended the nebula be referred to by its NGC designation in further publications.
Well, I have no problem calling it the Clownface Nebula.
It looks like an Eskimo to me.
We can call it the Eskimo Nebula. I think they're just getting too crazy.
I agree.
So the spider here has this beautiful orange star in it too. It's making a halo around here. But you can see the legs of the spider basically. And that really is pretty.
That's the Fly on the left.
Yeah, I believe so, yeah. Yeah, I mean, yes. Okay. Let's zoom out. There we go. You notice that these nebula courses all throughout this area. It's really something, you know. And I mean, no astronomer's worth his salt if he doesn't go from doesn't go from the Y cluster to the I'm sorry, it doesn't go to the letter Y cluster from the Spider and the Fly. So we'll check that out too. The Y cluster is the Tadpoles.
Yes. Probably offended somebody too.
Oh, it's fine. Let's just bring this back here. Okay, there's 15, so we'll pause it here. It's already named, and we'll save it. Save it exactly as seen. Alright, and we'll clear this now. It's on its way up to the server right now. Clear this, go back to our night vision mode. There we go. Alright. And now let's bring back our beautiful computer system and head over to the Tadpoles. It's not too far from here, so you're just going to see it. Yeah, you can't miss it. There it is. You say, well, what's that? You gotta look when we develop it for you. It's like developing film, you know. So we're gonna do this. Bring it up and go west a little bit. There we go. Go up a little more. And then we'll hold right there, because the tadpoles that we want to see is right there. Okay. And this will be a 45-second shot as well. First, before I do that though, let's just make sure focus is good. I'm going to zoom in. See if the algorithm's holding. It probably is, but I'm gonna do a focus run anyway. So there. So I will take us out. Okay. Oh, that's 45 seconds. Mistake. This has to be 1 second. Sorry about that. That's more like it. Okay. And then we're going to do a focus run. So we're going to go down here and say multi-star, full width, half maximum. And we're going to scan in. Alright, and you watch it become more focused as it finds stellar candidates for the focus routine. More and more as it gets more focused. You'll see the donuts change into tiny little dots, then go back out to donuts again.
One time.
You caught a tadpole one time?
Yeah. Brought it home, put it in a big fish bowl out in the garage, and go out and check on him regularly, and he was a good-sized tadpole.
Mm-hmm.
Went out and looked at him one day, and he had grown legs.
Mm.
And then his tail started going away, and I spaced him out for a day or two. I went back, and he was gone. I guess he had turned into a frog and jumped out of the fish bowl.
Yeah.
Never saw him again.
Here we are. There we go. That's what happens.
Yep.
Nature at work. I recently found a jar of pond water that was full of living things in it. And that jar of pond water I found deep inside a dark closet. And I remember sealing it, okay, when I was 15 years old. And it had never been opened again. Okay, for all those years. So, you know, over 45 years, it just stayed there in the dark.
Wow.
And when I opened it, when I didn't open it, when I looked at it, there was life in there, things swimming around. So I immediately thought Lake Vostok. Now, why would I think Lake Vostok? First of all, we're done with this. Now we got our perfect view here. Lake Vostok is under the Antarctic ice sheet by, several miles or so. Hasn't seen the light of day in thousands of years, hundreds of thousands of years, maybe millions of years. And there is an entire world unto itself down there. There's over 3,500 species of life living there in the permanent dark. And they are thriving. And long after humanity is gone, wiped itself out or whatever, Lake Vostok will continue deep under the ice sheet, oblivious to everything else. And just incredible. And so they have their own carbon cycle. They have their own cycles that are used, carbon cycle, there's the oxygen cycle, there's the chemical cycles that are used, methane cycles, CO2 cycles. All those things are self-contained in this lake. And I thought, wow, that's just what happened in my jar in the dark.
Oh, there
It
are.
was incredible.
There are lots of videos on YouTube of people creating little microbiomes. Like they close a terrarium, or they close off a big jug full of water, and they go back and check it periodically. And some of them have lasted for a long, long time, and you get to see the little biome evolve over time.
Oh, yeah. This is the tadpoles, and I'll explain the tadpoles shortly.
They do that.
Yeah, but watching a biome develop over time is very interesting.
Yeah. and sometimes they let them go a long time. And you'll see little critters show up in there that weren't there early on.
Yeah, that's kind of what happened with me. You know, and they started a concerted effort to open the lid to unscrew the jar, because I saw them with their dead bodies lined up around the top, pushing. You know, no, I didn't. That was a lie. But it's amazing, you know. And this is how I started my book, The Populated Universe. I talk about, you know, each creature as it exists in its little environment. Everything it can see is its universe. To a fish, its world is the water, but the universe to the fish is the sky, the place away from where they can survive. And for humans, our universe, okay, our world is, of course, Earth, and the universe itself, above the atmosphere, is that place out there, this place that we're looking at right now, you know, for us to go to someday. So, a toddler in a crib, toddler's universe, and the world is the crib, and the world outside the crib is his or her universe, you know. And as the toddler gets older, he's put in a playpen. Well, then his world is the playpen, and the universe is the rest of the world outside the playpen that they can look at, right? And as we get older, we expand our universe, our local universe. You know, when you ride a bike, your world is now as far as you can pedal on the bike, and the universe is what's beyond. You know, that street down there that you can never get to because it's too far away and mom told you not to go there. You know, that kind of thing. So that's how I view it, and that's actually it's a very good way of dealing with the very large astronomical numbers, because the problem with the numbers is they're just too big for us, right? We can't contemplate, as humans, we can't even think of 1,000 of anything. Right, 1,000 is about the upper limit. We can imagine 500. We could sort of see it, but 1,000 things makes our heads kind of go all mushy, because we never evolved to have to manage those kinds of numbers. You know, so even making an astronomical model, like you want to make a model of a solar system, you can quickly go astronomical with that. You know, for example, let's say that you make take a football field. And I actually did this with classes. I would take people out to a football field. We would do this. I would make the sun a softball. And then I would say, okay, where's Pluto? And Pluto was like in the opposite end zone. Okay, that football field. Where's the nearest star? The nearest star is down in Washington, D.C. You know, it's astronomical in terms of the model, even when you just start making a model.
There's a guy on YouTube, I can't think of his name offhand. He did that with, he set up a model of the solar system in a football field. I saw this just recently.
Okay.
And he took a dried pea, and that was the sun, and he put that down in one end zone, and the size of the rest of the solar system stretched to the opposite end zone, and except for Jupiter, everything else was just like a little tiny, like a dot drawn on a little square of paper that he laid out on some yard line.
Mm-hmm.
And then he went to the next star, Proxima Centauri. And I forget how far it was, but he had to drive into the next state to get to it. He was, yeah. I think he started in Utah someplace, and he wound up in Arizona where he could show where, by scale, where Proxima Centauri was.
Yeah. Similar. That's a similar model. It's all fascinating. There's no doubt about it.
You see the tadpoles now.
Yeah, these are the tadpoles. And we're actually looking at these little features right here. See these guys?
No.
There's one there. There's one here. Those are called the Tadpoles. And they're actually a little emission nebulae and clouds of dust and gas that are kind of doing their own thing there. They how they evolved, how they evolved is a mystery. Not sure how that happened. There's some ideas maybe that because of the young hot cluster, that they partially were shaped by this cluster here, because this is a stellar nursery, and that's very possible that these are stalks, kind of like the Eagle Nebula and many others that we've looked at. So that's really fascinating.
Sure.
So let's back out of this for a sec.
You talking about the baby's crib being the world at one point?
Yes.
Our mom used to tell a story on us when we were babies. My twin brother and I, our bedroom, they had two cribs, one for me and one for David, and they'd put each of us to bed at night with a baby bottle, and the cribs are on the opposite sides of the room.
Okay.
And they'd go in and look at us in the morning, and one of us had two bottles in his bed in his crib every night.
Oh, somebody's crossing the universe.
Yeah. Turned out there was like a chest of drawers in between the two cribs, and whichever one of us was climbing out, he was climbing over that chest of drawers and stealing the crib from the other, stealing the bottle
Still
from the other
the
crib.
bottle. Wow. Here's a better look at the tadpoles. They look pretty cool here. Let's add an unsharp mask to kind of give some more detail to them here. There you go. Look at that. Now you can see some detail in those. Isn't that amazing?
Mm-hmm.
That looks really pretty. Wow.
Well, it's one of those things as you expand your horizon, though, you know. I think you said, you know, like when you get your first bicycle, all of a sudden whole new realms open up to you.
That's right. Your universe, your local universe expands. You know, you can't even imagine the other side of town without getting in your spaceship, in other words, your car, with your parents and driving there. You can't imagine a trip to another state as a kid. You're trapped behind those windows looking out, finding yourself saying, when are we going to be there 100,000 times? But boy, oh boy, that's something else. Yeah. And what's interesting is, you look at stalks like this, just one stalk out in space, just one, like this guy. And the size of that is probably going to be maybe 25, 35 light years in length. I believe this particular nebula is further than other nebula nearby. So it's going to be a fairly long stalk. And it's like, you put our solar system in there, it wouldn't even show up. If, as far as we could zoom in with this right now, you wouldn't even see the circle of our solar system in there, out to say Pluto's orbit. And Pluto is a planet, by the way, to me. Hey there, C&D boy. Forgot to say hi. Oh, Poison Arrow wants the flaming star. I had a feeling that someone was going to ask for the flaming star. I just think the tadpoles have a lot of detail in them. Look at this.
Yeah.
Very cool. Okay.
Excuse me a moment, please.
Alrighty. So there you go. Poison arrow. I know it's close. All right. We'll do the flaming star tomorrow. No, just kidding. All right. And at the end of this, we'll do that. This is the tadpoles. Tadpoles. Save. Save exactly as seen. Alright. And I'll come back and go into the night vision mode as usual. And then alrighty. And yes, we can certainly go to the Flaming Star. We're gonna go to the Flaming Star, Captain. Scotty, we've got to go to the Flaming Star. I think it's very important.
I knew it.
And here we go. Huh?
I knew it.
Well, Poison Arrow asked.
Yeah, I know. You do the spider, the fly, and the tadpoles. You got to do the flaming star.
Yes. Why not? I don't disagree.
I think this is going to be my last object tonight.
Okay. Alright, let's just do this. There's a flaming star right there. We're at 300 gain right now. We're going to move it over to the west a little. I did the tadpoles at 200 gain just to kind of show some detail in the tadpoles. Okay. Okay, and now let's jump into the flaming star. Look, lots of flying birds.
Well, it's funny how you, you know, as you grow, that you're always gaining new horizons.
That's right.
Remember, I was probably about 5 when I learned how to walk down to the little girl's house at the other end of the block, and you know, I had a new friend.
I know.
And
You met an alien.
Hey, first girl I ever kissed. She was so cute, I couldn't help myself. We were in the basement one day. We were about 5, and she was so cute. I just gave her a big.
Do I need to mute you?
Smacked her. No, you know, it was innocent.
Yeah, of course.
But
There you
then, you know, when it came time to go to school, our school was 4 or 5 blocks right up the road, and we could see it if we stood out on the corner of our property. And then you walked to school, and then you found out there's a whole other world over on the far side of that school. And
That's right.
got your bicycle, and before you knew it, I was riding out of town to my aunt's place, carrying a .22 rifle to go out and shoot. This was back, you know, if we did that nowadays, somebody saw a kid carrying a rifle, they'd call the cops. And back then, nobody cared.
That's right. I remember my my father would go to Maine, my father would hand me a 22 and he'd say, all right, go out and shoot stuff. Okay.
Yeah.
I'd carry a box of bullets, you know. I'd go through that box of bullets. I'd be shooting at targets. I'd be shooting at shells, you know.
Oh, yeah.
It was just crazy. All right.
That 22 was a 1910 Springfield single shot 22. The gun is still in the family.
Wow.
I haven't seen it in many years. Number 2 brother has it. Hopefully he's taking care of it. Probably use a good cleaning. But it's not,
Well,
not
if he's
rusted.
still firing it.
No, he's anti-gun.
Okay.
But, he's holding on to it just because it belonged to our father and his father.
Mm-hmm. There's the flaming star. There you go, poison arrow. Izabela, you're funny. Here, let's get the color right in the nebula. There we go. This nebula, I used to be kind of bored by this nebula for whatever reason, I don't know. But when this resolves better as we get more stacked, you're going to see these blue tendrils amongst the red. Well, this is a beautiful red hydrogen emission cloud, right? Ionized by the hot stars in the area. And then the star's blue light is being scattered by some of this dark dust, which is mingled in with the hydrogen. And where there's more dust than there is hydrogen, the blue reflection nebula dominates, right? And that's what we're seeing here. And of course, you see all these little areas of dark dust. Very complex twists and turns for all this material. And once I started seeing how complicated this region was, it became almost a favorite.
Yeah, I've seen and remember Izabela used to not like the flaming star.
That's right. And then she saw it with the tadpole and spider and fly in a composite.
Yep.
And what we're doing tonight can be composited too. They're all close enough that you can composite them and see three images all connected, but without the intervening. And there's some missing ones, but it's okay. It's fine.
No, it's all baby steps, turn into big steps. And
Yeah.
remember, by the time I turned 21, I had a 1964 Volkswagen. I put everything I owned in the back seat. I had $100 in my pocket. I moved to Colorado. That was an adventure all of its own.
I bet, because you went to Leadville.
Oh no, not at first.
Okay.
I lived in Summit County, Breckenridge for 4 years before that.
Oh, all right. All right, so let's try to clip some of the noise out of here. And let's back out a little bit. Wow, there we go. Beautiful. 8 stacks so far.
Ray's a comedian.
Yeah, I mean, OBAFGKDD for Daryl.
Actually, he was talking about Cygnus.
Okay, but above that, he was said.
Yes, I know.
You know.
I saw that. If that's referring to the girl, I guess. Izabela said the same thing too. Her name was Cheryl. She was cute as a bug. And I fully intended to marry her when I grew up.
Have you ever looked her up to find out what became of her?
Actually, I did once. A while back.
Were you intrigued or disappointed?
No, she's grown up too, and she's a spitting image of her mother.
No.
Her mother was the first lady, female, whatever, besides my mother, I ever had a crush on. Again, I was probably 4 or 5 at the time, and my shoelace came untied one day, and I asked Miss Springston, would you tie my shoe for me? And she did, and she was really nice about it, and I developed an instant crush on her. Looking back, I untied my shoe about a half a dozen times just so I could get her to tie it for me again. I was in heaven.
That's funny.
But no, the girl, Cheryl, she spit an image of her mother, and she's evidently divorced and doesn't have the same last name anymore anyway. And that was that.
Wow. I like this area right here. Let me show you this. Check this out right here. There's a orange red star. There's a red star in there. I'm not sure if it's giant or if it's just subgiant or something. I don't know. But it looks like it has something to do with this red nebula here. Not sure if it does, but it looks like it does, and that's really pretty cool. I'd love to know what's going on in there. But here's what I was talking about before, guys. What I was saying is, here you see the black border. On the other side, you see the red. Okay, this red is the hydrogen emission that's taking place, and on the black, there's hydrogen gas in there too, but it's not being ionized on that side, at least not to the same level with the density of the dark material there. So it shows through here, but doesn't show through on the backside. Kind of interesting, you know. It's actually a very interesting location, and you see this real detailed, circuitous path of this black stuff. And why is it so spindly here, but not so spindly in other places? We have seen like the Casper the Friendly Ghost Nebula. It's spindly down the bottom. Okay. But this looks very spindly, perhaps because there might be electrical charges in this nebula that are forcing some shapes and predisposing some shapes of these tendrils, similar to the Veil Nebula. It's a supernova remnant, but there might be charged particles there that are causing them to become spindles as well. It's an interesting theory. I'd like to know if it can get... I'd love to see it get... I'd love to see it get proven, you know?
Well, if you look up above that, there's that other red tendril up there.
Yeah.
A couple of them.
That might be from here as well.
Yeah.
Not sure. It doesn't appear that this star might be doing it, but it could. Could. I'll have to find out what this star is. If this star is like a red giant, then it's not doing this, because it certainly isn't hot enough to do that. This would have to be some other kind of young hot, more young hot star. Because giants are very low temperature. Supergiants are low temperature. Betelgeuse can't ionize anything, okay, but you can get ionization from, say, Rigel or Alnitak or Analam, Mintaka, Safe, Bellatrix, but not Betelgeuse.
Blue supergiant
Betelgeuse is
sure could.
too cool. Yeah, of course. But red supergiants, not really. Temperature is only like 3,500 Kelvin, and that's not hot. That's not hot enough. But you do get some emission associated with some giants as well. And that's a possibility as well. Depends on the giant type. Okay, we've done 18 of these. We're going to go to 19, and that'll be that. Going to 20 won't make much difference here. So we're going to pause this, and let's go up here, name it Flaming Star. There it is. Alright, so we'll save it, and then save exactly as seen. Nice. And then we're going to go back. There's the whole nebula. That's pretty. It'll be up there.
And I hear the pumpkin coming.
Yeah, you want to go. I know. You're right. Okay. Well, yeah, you can certainly take off if you need to. I'm just trying to go to Cygnus for Ray.
Okay, you're not trying to go to the comet, are you?
I don't think I can get to the comet from here. What's the actual elevation of the comet right now?
Give me a second, I'll find out.
Alright.
The comet is 25.1 degrees above the northeastern horizon right now for Colorado, and take away 6 degrees for you, it'd be 19 some odd degrees above the horizon.
Yeah, it's about this altitude above the horizon.
Yeah, about 2 hand spans.
And it's in Draco? Okay.
It's
Yeah, it's very low.
It's just to the lower left of lower right, that is, of Kochav and Ursa Minor.
Yeah.
Front star in the bowl. Little Dipper. Sky was clear here, and, well, not here in town, but if I felt like driving out of town this late at night, I could probably catch it, but it was the binoculars by the time I got out of town.
Mm-hmm. Yeah, it is not in a good position. We can't see it yet. But it's on its way up toward Polaris, and it'll be above Polaris in just a few days.
Yep.
Actually, 6 days we'll be able to watch it. We'll be able to see it by then.
Hopefully not that long.
Well, we got the moon that's going to cause problems anyway.
Yeah. This time of night, by the 28th, 4 days from now, it will be a little bit higher than Polaris. It'll be just to the right of Polaris.
Okay.
About the length of the Little Dipper's handle.
Gotcha.
By then it's 41 degrees up here, so it'd be 35 degrees up in Arizona.
Yep.
Maybe by the 28th. Weather permitting.
Mm-hmm. Okay. All right, so as you know, I'm always Marc do one more Dantonio. So we're gonna do measure just 81. We're not gonna do 82. So it's up there, right? But we're gonna just focus on measure 81. So let's drop that down and head east a little bit. No, head west a little bit.
One more.
Yeah, that's me. As you can see where the telescope is pointing, it's pointing just over the north wall. So it'd have to be way looking down to see the comet. All right. Now this is the last one. And M82 will show up on the image, but we're going to focus on this. We're going to zoom in on this. M82 is a starburst galaxy. There's stellar formation going in at a prodigious rate, possibly because of interactions with M81. All right, so let's just get us into our position that we want to be in. Here we go. Okay, and this will be a 30-second shot. We're getting our guide set up, going. Thank you, Izabela, for putting up those links to the objects, which you can find at SkyTourLive.org or com. All right, here we go. We got 30 seconds. 30 seconds on the clock. And begin. That really is pretty. It's a very complicated region. I've changed my mind about it. I really find it to be a fascinating region. I know you're tired, Daryl, so this will be the last one. I mean, I don't need to do this, like, make sure you're around, but it's okay. When you get tired, I'm usually tired as well. There we go. There it is, and we're gonna just get some more detail now.
Oh, it's a nice galaxy.
Oh, it sure is.
I may have
Look, even up there, a satellite.
I read somewhere that M81, they do not think there are any density waves going on.
Yeah, so the spiral arms could have been generated by interactions with M82.
Yes.
Oh, okay. Alright. Alright, so let's do this. Look at the core. And bring it up and just start to get a hold of some more data and more details. Okay, let's start with that and zoom in. Interesting, you can see what look like H2 regions in the outer arm here.
A lot of times, if you look at a galaxy, a spiral that's interacted with another galaxy, it's kind of misshapen or lopsided.
Yeah, the disc is warped.
M81 here looks quite symmetrical.
Well, this could be going way up into space, and this could be going down. We don't know, right? We'd have to look that up and see if that's actually been properly studied that way. I'm sure it has. They've figured out the proper motions of the gases that are seen spectroscopically. You can tell how fast gas is moving toward or away from you by checking out where the spectral signature is, and if it's shifted toward the red, it's moving away from you. If it's shifted toward the blue, it's moving toward you. And you can build a vector based on repeated observations too.
Yeah, but just to the casual glance, it looks quite similar.
It does. It's really pretty though.
Looks like there's a little dead patch over to the left of it.
Yeah, like right here. Oh yeah, now we talked about that, remember? Wasn't sure if that's a dwarf galaxy or something, but it shows up in every photo, so it's really there. I turned off enhancements so that we could see the detail in the core of the galaxy. When you turn on the unsharp mask, it tends to blow that out. That's nice. Very nice. We'll darken up space a little bit. Lewis, yes, Lewis, M82 is above it. It's in this field, actually. If I zoom out, you'll see it. So you'll see that it will be also on the frame. So we could zoom in and you can see it, and you'll notice that M82 has these spindles of hydrogen gas coming out of the core and heading straight up into space from there. Look at that. And the destructive look of that galaxy is due in part, or entirely due, possibly, to M81 and how it interacted with it. Okay.
Now that you say that and show that, the spiral arm on the left of M81 does look different than the one on the right. It's much wider and
Disconnected.
more pronounced, and it has that disconnection that it does.
So that could be the result. We don't know.
Yeah, well,
I think it's neat though.
mentioned the whirlpool before in 51 that the one spiral arms looks like it's, certainly being affected by the satellite galaxy. And maybe
And in fact,
that is what we're seeing there.
well, in fact, that is with the whirlpool. When we look at the whirlpool, one of those that spiral arm near the satellite galaxy is actually bent down to the satellite galaxy, which is further behind it. So it is a true warp that's occurring there.
Can you back out enough just to where we can see both?
Yes, I just did, but I'll do it again.
Yeah, maybe it's just my imagination. But, yes, to me it looks like the left-hand spiral arm in M81 is more pronounced. And it's kind of pointing up in that general direction.
Yeah, I don't know if that has anything to do with it. It depends on the three-dimensional positioning in space relative to each other. But M82 definitely got the short end of the stick on it, that's for sure. You know? Indeed it did. Okay, this is 14 images. Let's go take one more look at M82 up there. Wow. Okay, so you can see these beautiful spindle structures. Look at them. They're just sticking right down here. And going up. Very nice and clear. And then as you drop down, M81 comes into view. M81 is interesting because it doesn't seem to have too much variation in it. It seems like a galaxy without too many knots yet. If you look in here, it kind of belies that. It looks like there's a whole host of hydrogen emission regions in here. And look at this arm. All throughout this arm. Very congested in here.
And I think the one on the left there, the one at about 7 o'clock right there, it looks sort of different than the one that was top right.
Yeah. There's certainly lots of dust in this galaxy. You can see it right here. Very interesting.
Look really close at the one at the top right. Looks like there's a faint little extension of it coming off some kind of hook shape.
Right here?
Right up the very top of it.
Oh, up here?
Very top, right there.
Oh, right there?
Yeah.
Oh, yeah. Again, could be potential interaction with M82. Alright, this is good. So we'll have 3, 2, 1, 0, boom. Okay, 18. And we'll save it. And then we'll save it as seen. Wow, guys. How about that, huh? We had another fun night tonight, didn't we? I hope you guys enjoyed it. I did. I had a lot of fun. And we spent time digging through some stuff, and we took Izabela on her tour. Ronald, get ready. Come up with a list. If you don't have a list, let us know what kind of things you want to look for, and we'll show them to you. Because your journey's next, my friend. Thanks, folks. Again, you have wasted another fine 4 hours, actually 4 hours and 5 minutes with SkyTour LiveStream. So hope you guys enjoy yourselves. Have a good evening. And we will talk soon. Daryl, thank you for being here.
Sure. Thank you for having me. Good night,
course.
everybody.
Good night, everybody. Have a good night, and we'll see you the next time we do this. And who knows? I can't stay away from the sky. And neither should you. All right, guys. Good night. Have a pleasant tomorrow.